stream it, live stream it. If you go to the eCYBER18 website, right there on the front of the page, there'll be a little link that you can click on. You can go and watch the luncheon tomorrow. So I want to make sure that you got some energy in here today. So here's what I'm going to do. I need everybody to just stand up right where you are. Stand up. Stand up right there. Yeah, everybody, not just the students. Everybody stand up. And here's what we're going to do. We're going to play a little game that the 6th and 7th graders already know. It's called Tiger, Martian, Salesman. All right? All right, so if you're confused, watch the 6th and 7th graders. They'll lead you through it, but it's pretty simple. When I say the word tiger, I want you to put your hands up like they're claws and go, grrr. Let's see that, everybody. Tiger. I can see you. This is not TV. All right. When I say Martian, I want to put your hands up like the antenna and go, beady, 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 beady. Let's see that, Martian. Oh, that's very good. That's very good. That was adorable. And finally, when I say salesman, I want to put your hand out like you're about to shake hands, and in the smarmiest voice you can, I want you to say, hi there. Let's try that out. Salesman. Very good. All right, so I'm going to say those three things, tiger, Martian, and salesman. I'm going to change up the order, and I'm going to increase the speed. I need you to keep up as well as you can. All right, you ready? I say, you ready? All right, here we go. Tiger. Tiger. Martian. Martian. Tiger. Salesman. 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 Tiger. Tiger. Martian. Martian. Salesman. 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 Tiger. All right, freeze right there. Freeze it, tiger, and turn to somebody and go, grrr. Turn to somebody else and go, grrr. Very good, ladies and gentlemen. Consider yourselves pumped up. Have a seat. Give yourselves a round of applause. All right, now I want to make sure that we got some noise in here. And also, on everybody's seat, there was a sign. What does it say on that sign? Wow, that was cool. Let's try it in unison. What does it say on that sign? That's right. Now, that's the hashtag you need to use to let everybody know where you are, what you're doing, all your pictures, all your tweets, all your Instagram stories. I don't know things. Do we still use MySpace? Is that a thing? No? Okay. So use that, all right? And whenever we ask you to, you can hold those signs up and show them around, because we are live streaming this all across the world. All right? People can be watching this anywhere they have the internet. So keep that in mind. Show that enthusiasm, all right? When we're applauding for our teams, when we're getting excited, get excited and show them. I'm going to do a little thing right now over here on this side, and I'm going to, just in the back, I'll split you like just kind of right down the middle. On this side of the room, I want you to say, eCYBER, go. eCYBER. And on this side of the room, I want you to say, mission, go. Mission. All right, let's try that again. You got it. Give yourselves a round of applause, everybody. Great job. Great job. All right, keep that enthusiasm going. Keep that applause going, because, ladies and gentlemen, I want to introduce our MC for today's National Showcase. It's the SURDEC Outreach Lead, Erica Bertoli.
Whoa, now I got it right. Sorry. So, kids, have you been having fun this week? Really, that's it? Have you been having fun this week? Hey, have we tired you out so much that you just want to skip this and go to bed? No, because this is the fun part. This is the showcase. This is the part where you get to strut your stuff. You get to show off what it is you have been working on all year. So first things first, I want to make sure that we are welcoming our distinguished guests, our parents, our families, our friends, everybody, our team advisors. Give yourselves a hand. You survived. And I want to thank all the people who are out there live streaming on Ustream and watching us at home. Everybody look and say hi. Outstanding. So for those of you who are watching us on live stream, don't forget, you can participate. It's almost like you are here. You will notice that there is a chat section. Make sure you are letting your voice be heard. Make sure you're commenting, you're asking questions. After each of our groups of students, we will be checking in to see what some of those questions are. We will be going into our audience, and we will be doing that with the lovely Colleen at the Go eCyber desk. Say hi, Colleen. So Colleen's going to be reading all those comments and questions and sharing them with us. And I looked last night just because, you know, I'm nosy like that, and people were already chatting online. They were already getting on there, and they were all talking about one thing, the People's Choice Award. Who thinks they got this People's Choice thing in the bag? Really? Wow. I guess I get the iPad? Who thinks they've got the People's Choice thing going? All right, that is better. The People's Choice, our amazing students, they competed today for the national judges to find out who the national winner at the grade levels are going to be. And tomorrow they'll find out those results, but they're not the only results, because tonight, you, the people here in the audience, everybody, you get to vote for your favorite eCyber mission project, the People's Choice Award. For those of you who are viewing online, in your little screen viewer, right on the bottom of it, there's a button. And that button says, vote for the People's Choice. Click that, vote for the People's Choice. We will remind you a lot. For the people who are here, if you go on your phone, which is of course on silent, but if you go on your phone and you go right to the eCyber Mission homepage, you will notice the link right there to be able to vote for your People's Choice Award. And we want to make sure everyone is participating. You will have tonight until 8 p.m. Eastern time in order to get those votes in so that they can be calculated. And do you guys want to know what you win if you're the People's Choice? And somebody told you. You get an iPad. So NSTA has donated iPads for the winning People's Choice team. So everybody, thank you, NSTA. And of course, just like Matt said, we want everyone everywhere to know about eCyber Mission. We want them to know about the amazing work you did. We want them to get engaged and compete next year. And we want to be talking about it. So Facebook, tweet, do all of it. Hashtag eCYBER18. You guys are going to do that, right? Yes, I've seen you guys have been doing it all week. There have been some amazing pictures, that whole hashtag thing. And does anyone know what the other big hashtag today is? Hashtag National Selfie Day. So we are going to borrow Colleen's phone. I'm going to come down here. Thank you. I'm going to leave that there. And okay, let's see. How would I do this? All right, we're going to go right over here. And my arms are really short. But come on, we're going to do our first National eCyber Selfie. Oh, we're going to do another one on this side. Don't worry. My arms aren't long enough to be able to get both sides at once. So let's see. All right, everybody, you ready? National Selfie! And we're going to make sure we tweet that out so that everybody's seeing what a good time we are having here. Thank you. So, before we introduce the teams, we want to take a minute and make sure that we acknowledge the team advisors. Come on. All of our students here, and these are some incredible students, they are clearly a product of your talent, your dedication, your willingness to go above and beyond and help them out and guide them. And it's an amazing thing to behold. I got to see some of the projects, and this is a far cry from like the solar system diorama I made when I was in middle school, when Pluto was still a planet. So these kids are just outstanding. Now, this week was jam-packed. They did everything. They went to DC, they toured the monuments, they met with legislators, they went to Army Lab Day yesterday, and they got to engage with some of our Army and scientists and engineers who brought out technology and led them through some of those activities. And all through this week, they've had some amazing people with them. First and foremost, they had an incredible group of Army scientists and engineers acting as their SME mentors who stayed with them. That's, yeah, clap for them. The SME mentors were with them all week, helping them, guiding them, and sharing what their experiences are working in science and engineering, giving them that really valuable insight as young and up-and-coming, amazing generation of STEM. Together with the SME mentors, we were so incredibly honored. We had an amazing group of our United States Army soldiers with us this week. And our soldiers hung out alongside the students. They taught them about Army values. They taught them about perseverance, teamwork, all the things they are going to need to succeed. So, of course, as I said, it was a busy week. But in between all of that, the NCOs taught them a little bit something else. And I'm going to invite Sergeant Julia Sanders up here. Give her a hand. And she's going to take us through a demonstration of what the students have learned. Awesome. Now, we got a little bit more for you. So I am going to give you some information about the amazing things that happened in eCYBER18 this year. And for each one of these pieces of information, I want to hear a good hooah. And if I don't hear a good hooah, I'm going to bring Sergeant Sanders back up. She's going to make sure you're on point with this. All right, so you guys ready? This year, a total of 22,391 students participated in the eCYBER18. Okay. I was checking. She's the expert. 869 team advisors led 5,995 teams in 52 states, U.S. territories, and DoDEA schools overseas. 2,560 volunteer virtual judges, 24 regional judges, and 14 STEM in action judges volunteered their time to review the mission folders, listen to regional judging presentations, and review STEM in action grant proposals. So we started with 22,391 students. Today, we have 78 from 22 teams sitting in this room. Congratulations! The students and the projects that you guys are going to get to see here, our guests in the audience, these are among the best, the brightest, the most amazing our country has to offer. These kids have looked into the world around them. They've found ways to leverage science, technology, engineering, and math to solve real problems, to make the world better, to look into the future and see how they are going to create the world that they want to live in. And I know that if this is the future of STEM in this nation that I am looking at, we are very lucky. Give yourselves a hand. You guys are fabulous. So now, are you ready to get started? All right. Now, don't forget, vote for the People's Choice Award. Head over to the eCYBER18 homepage. Click that link. Use the button under your viewing screen. Use that link. But make sure you vote. Each name gets to vote one time. You have until 8 p.m. Eastern Standard Time. But vote, vote, vote. The more the merrier. Tell your friends, your cousins, your third grade teacher. Get everyone to vote. And we're all going to use what? Hashtag? eCYBER18. There it is. So let's get going. This afternoon, we are going to start with a group of students, our STEM in Action awardees. So, as all the teams know, all regional finalists are given the opportunity to compete for a STEM in Action grant. This means that the regional finalists create a proposal, and that proposal outlines the team's plan to formally implement their project in the community. A select group of STEM in Action judges review all of these proposals. They evaluate them, and the top 5 teams are awarded as AEOP STEM in Action awardees. Each of the 5 selected teams receives an award of up to $5,000 and are invited this week to the National Judging and Education event. In addition to coming to the event, eCyber Mission will work with the STEM in Action teams throughout the year, help them bring their ideas to life. STEM in Action teams can be, but are not necessarily, also national finalist teams. This year's STEM in Action grant recipients come from the 6th, the 7th, and the 9th grade. We're going to hear from them first, because when they are done here today, they will be spending time with the National Inventors Hall of Fame staff to discuss their next steps on their road to greatness. So, our first team that we are going to bring up is Team Blazing Radiance. They are 6th graders from Maryland. Go ahead. In addition to being the STEM in Action winners, they are national finalists representing the Northeast region. Blazing Radiance is led by team advisor Sakshi Amula, and it is comprised of team members Advika Agarwal, Shusti Amula, and Angelina Shru. Ladies and gentlemen, they, in an effort to detect forest fires and prevent damage to life and property, Team Blazing Radiance developed FICSS, the Fire Indicators Combined to Save Souls. They are from Roberto Clemente Middle School in Germantown, Maryland. Give it up for Blazing Radiance.
Along with losing their 14-year-old son. Another example of the destruction that wildfires can cause were the 2004 Alaskan wildfires, which produced 30 billion kilograms of carbon monoxide into the air. Not to mention this graph, which shows how the number of wildfires and acres burned has increased dramatically since 1983. But wait, fix and help. Since we're optimists, these issues became the inspiration for FIX, which is placed in a forest to detect wildfires early on, preventing damage to life and property.
To embark on our journey to create FIX, we researched wildfires, brainstormed components, ordered them, tested them individually, wired them, wrote a program to read the different outputs, encased FIX, and tested FIX as a whole in a variety of different conditions. FIX has 2 sides, the transmitting side and the receiving side. The materials we use to create FIX is an infrared sensor, a GPS, 2 LoRa or long-range transceivers, and 2 Arduino Uno microcontrollers, which is like the brain of FIX. Here's how FIX works. First, the Arduino script is loaded into my controller. Our infrared sensor is constantly looking for fires, so when there is a fire, it sends an output of 0, and when there isn't a fire, it sends an output of 1, and FIX will continue monitoring the area. When there is a fire, the Arduino Uno acquires the GPS coordinates. The information is then sent from the transmitting LoRa to the receiving LoRa, and then to the receiving Arduino Uno in the authority's office. The information is then input into a Google form, a Google Sheet, and then into the Google Fusion table. The Google Fusion table has an inbuilt Google Maps function where it visually displays the fire locations. In addition, we also wrote a program to send an email alert to the firefighters with the GPS coordinates. Both our blueprint and our model show how FIX is positioned in a real-life forest scenario, where the transmitting side is placed in the forest and the receiving side is placed in the authority's office.
Now we'll demonstrate FIX in action. I'm moving FIX farther away from the flame, which I've already lit. Wow, I'm so lit. And we, or the firefighters, should now receive the email.
This is the email which we just received. This is written in the National Marine Electronics Association format. Also shown is our Google Maps, where the green icons represent the fire locations.
The IR sensor could detect from 2 feet at a 45-degree angle. To test the LoRa transceiver, we drove the transmitter farther away from the receiver until we stopped receiving the email at 330 meters. We also tested water durability by leaving ice and water atop FIX, which was never damaged. Right now, there are not many early wildfire detectors in place, so firefighters rely on limited, delayed information from callers. But Fix sends specific info to a convenient device to start the firefighting process earlier and make firefighters know the way.
Teamwork makes the dream work. We start off by splitting the mission forward questions between an answerer and reviewer, and also use the Google Sheet, listing the assignments, due dates, answers, and reviewers to collaborate more efficiently.
Our roadmap includes adding a thermal camera, analog IR sensor, components with larger ranges, and much more, as well as contacting fire stations and parks to implement Fix.
The severity of wildfires increases every year, from how many lives are lost to the amount of money being spent. But we all must remember that way can be different with Fix. Problem.
Fix.
Solution.
A fixed problem is a solution.
All right, let's hear it for our first team, Blazing Radiance. They were fantastic, yeah? All right. So, who's going to come up next? Up there, setting the team. I'm going to ask Colleen while we're getting them set up. Have people started logging in?
They have, and I just found out we've got over 500 votes already.
Over 5, I don't know, and that's all this one team is the only ones that went. So we want to make sure everybody votes. They're going to vote early. They're going to tell all their friends to vote, and then they are going to comment and let us know that they are all ready to go. Oh, there they go. We're going to get ready for our second group, are going to set up now. Our next STEM in Action team are the Brainiacs with Blue. They're 7th graders from Oregon. Brainiacs with Blue are also one of our national finalist teams, and they are representing the West region. They are led by their team advisor, Sridhar Manakali, and they're made up of the students, Sankalp Gadam, Shrika Gantha, Anish Lagadu, and Onvita Malu. Team Brainiacs with Blue endeavored to find a way to ensure that the bioswales, which help filter stormwater before it reaches lakes and rivers, are working effectively while reducing the costs associated with quarterly inspection visits. From Portland, Oregon, please join me in welcoming Brainiacs with Blue.
Hello, everyone. We're the Brainiacs with Blue, and we have a skit for you.
I'm not too excited about this. I wish there was an easier way to do it. Sometimes there are no problems, and sometimes there are too many.
That is so true. What are you guys doing? Are you gardening?
No, we're maintaining a bioswale.
What's a bioswale? I don't think I've ever heard of one before.
Bioswales are low-impact development solutions, or LIDs. Bioswales are specifically designed to filter out stormwater, and to do this, it uses many layers. It uses plants which absorb the bulk of the pollutants, uses soil, gravel, and even a filter sheet. It uses an outgoing pipe to transport out the filtered water to the nearest body of water.
There is a federal requirement to have lids built into new neighborhoods. This will help increase the current 30% of neighborhoods that do have filtration systems.
I heard you guys talking about problems earlier. What kind of problems do you face with bioswale maintenance?
Some problems that we face are the lack of awareness, replacing and watering of plants, trash, weeds, pipe clogging, and stagnant water.
Wow, that seems like a lot of work. How much does it cost?
It costs from about 6 to 21 cents per square foot to maintain a bioswale.
Cool, thanks guys. I learned a lot about bioswales.
Bye, kid.
As clean water service experts,
Oh my gosh, all the volunteers are complaining about how hard it is to maintain a bioswale. We need a solution for this. Oh look, it's a solution for maintaining bioswales. Let's call these people.
Hello, we are Brainiacs with Blue. How may we help you?
hi, Hi, we work at Clean Water Services. We wanted to learn more about your solution for bioswale maintenance.
Sure, we created an app called BioPro that can track the maintenance of trash, weeds, and plant status, and we can analyze this information for one bioswale or a certain number of bioswales in a specific area.
How do I analyze this data?
To go into detail, we have a log that tracks problems, costs, and visits, and a dashboard that analyzes this data and creates a report for it.
Apart from this, we also have reminders that we can set for certain maintenance aspects and a way to share this information with other organizations in case they are unable to maintain their bioswales.
What kind of reminders can I set?
Well, first, we have a list of common ones, like to water your plants 90 days after the bioswale is built. However, you can set your own reminders.
The reminder feature would be really helpful, especially because a lot of our volunteers are forgetting about watering the bioswale's plants for the first 90 days.
Yeah, our solution can also detect pipe clogging, water stagnancy, and soil moisture via sensors.
What are the sensors and how do they work?
The first sensor is the water flow meter, and this compares the capacity of the bioswale to the average inches of rain which the user inputs. This can be placed near the outgoing pipe.
Now we can know beforehand if a pipe is clogged so we can fix it before it affects the filtration of a bioswale.
Yeah, our second sensor is the water level sensor, and this checks the level of the water twice a day, and if it is the same, it indicates stagnant water.
Stagnant water is a huge problem, especially because it attracts mosquitoes, which affects the surrounding neighborhood.
Yeah, our last sensor is a soil moisture sensor, which tracks whether the plants have enough water. This is useful mostly in the summer.
I'm sure you're worried about the cost. Well, the cost for the sensors, powering them, connecting them, and installing them costs about $140, plus the $15 per month for the cloud server.
This solution will really help with maintenance, and our volunteers' work will be much easier.
We got similar feedback from the stormwater engineers that we shared our solution with.
One problem that we face is awareness about bioswales. Do you have a solution for this?
Yeah, that's one of our future improvements. We're planning on integrating with Google Maps to provide bioswales locations to help raise awareness. We are also creating a minimal app that allows crowdsourcing, or people that live near bioswales to report on the maintenance conditions of them.
Our solution can save about 20% of the maintenance visits, and any money that has been gained can be used to build new bioswales.
Thank you so much. Now we can filter more water and help our environment more.
Stormwater filtration makes a better nation.
All right, let's hear it for the Brainiacs in blue. Nice job. So I'm going to take a moment, and I'm wondering at our Go eCYBER social desk, what's going on? What are people saying?
All right, we've got over 1,000 votes now.
Wow.
So it doubled in one presentation, so that's great.
All right.
And we got a couple people saying great job to Blazing Radiance, and the votes are in.
Oh, it sounds pretty exciting. So, you guys waiting for your turn? Yeah? No? I get to spend all week with them, and now they usually ask me questions I can't answer, so now I have a couple hours to ask them questions that they can't answer. So, the team that we are going to see next is also a STEM in Action team. They are Mission Water Smart, they are 9th graders from Illinois. Mission Water Smart is also a national finalist team, and they will be representing the North Central region. They are led by team advisor Sudesh Nair, and they are made up of team students Ahana Narayana, Manasvi Tamu, and Shivani Venkatraman, to stop Americans from wasting an average of 40,000 liters per household per year. Wow, it's a lot. Mission Water Smart created a device. It attaches to the faucet and automatically heats the water to a comfortable temperature as soon as the faucet is opened. From Aurora, Illinois, please welcome Mission Water Smart.
Smart Faucets by Mission Water Smart. Hi, we are Ahana,
Manasvi, and Shivani from Wavanzi Valley High School, here to introduce the solution to a problem affecting millions of people around the world. So, what is the problem and how does it affect our community? Water is a scarce resource, and America's water footprint is huge compared to other countries. We contacted our local alderman and mayor and realized that many communities, including our own, are looking for ways to reduce water wastage and encourage good water-saving habits. After contacting our local alderman, we realized that we wanted to figure out where in households water was being wasted, and found that 39% of water used in households is from faucets and showers. So we were able to separate the wastage in these two categories into behavioral wastage and negligence. Behavioral wastage is wastage caused by human habit, like reading the newspaper while waiting for your shower water to heat up, which wastes a lot of water. Negligence is wastage caused by human oversight, like leaving the faucet running while you brush your teeth, which also wastes a lot of water. Closely related to both these issues is the issue of cold water resting in the hot water pipes, forcing people to wait for that water to warm up. After doing some measurements and calculations of our own, my team found that behavioral wastage and negligence related to faucets and showers waste around 50,000 liters of water per family per year.
That's a lot of water, and we wanted to come up with a solution. For our solution, we wanted to avoid the two types of water wastage we mentioned, and in order to do this, we would need to include two things. The first was a heater in order to heat the water and avoid wasting it, and we wanted a way to encourage water-saving habits and make our device convenient. So, we created a smart faucet device. It can be easily attached to existing faucets and addresses the two things we needed most. So how did we build it? Well, first, we built a heater and connected it to the hot water input. It heats up the cold water resting in the hot water pipes and keeps it from being wasted. The heater is controlled by a microcontroller switch, which turns the heater on and off when the water temperature goes below or above a certain level. The output of this goes through a thermostatic mixing valve where it is joined by the cold water input, and they're both mixed to a comfortable temperature in order to avoid scalding. The output of this then goes to a solenoid valve, which splits into two outputs that lead to the faucet. The solenoid valve is also controlled by a touch sensor. This way, the faucet can be turned on and off with just a simple touch. In the process of creating our prototype, we faced some challenges with our parts. Some parts were not strong enough, so we had to use multiple microcontroller switches and solenoid valves during many iterations.
Now let's move on to the results and community benefit. Our project saves 35,000 liters of water per four-person family per year, around 75% of the total water wastage, which is a lot of water. Our project also costs around $100, which is already much less than other existing solutions and can be made cheaper if we sourced our parts properly instead of buying from retail stores. Additionally, although the operational cost of the device was not our main concern, the cost of the electricity used in the device is less than the cost of the water wastage, meaning you save money. Now let's move on to our future plans. First, the improvements that we'll make to the prototype. We'll make better calculations using larger sample sizes to see a better view of the problem. Then we'll make a feedback display to see how much water is actually being used. After that, we'll strengthen our heater to heat up the water faster, saving more water. Now let's move on to our go-to-market strategy. After refining our prototype, we'll define what the target market is. Then we'll spread awareness about our device through our local city councils, community events, science fairs, and the internet. We'll partner with manufacturers to produce the first batch of our device. We'll partner with our local city councils and potential corporate sponsors to gain subsidies or grants, and then we'll launch our device to our community. And based on their feedback, we'll refine our device and launch to others. Be smart. Water smart. Thank you.
All right, Mission Water Smart. Great job, great job. So while we're waiting for our next team to come up, I am going to invite Master Sergeant Sanchez up. He was our NCO in charge this week. Give him a hand. He is from our U.S. Army RDECOM headquarters. So, did you have fun this week?
Yes, ma'am.
A lot
of fun.
What was your favorite thing?
PT, when we all work out. Some teachers were having fun. Some not.
Did you guys like PT? They don't seem convinced that they like the PT.
They didn't like the workout.
Oh. Because, I mean, I don't know. I guess after this, you could take them for more PT. What do you think? You want to do more? No? Yes, some? What about the DC trip?
It was too early. the morning, 6:30.
Well, let's give a hand to Master Sergeant Sanchez, our NCOIC this week. Thank you. So our next STEM in Action team is Team BB Davis. They are 9th graders from Hawaii. Team BB Davis is led by Team Advisor, Miss Ana Maria Meru, and it is made up of students Ryan Wynn, Thomas Nuchan, and Summer Royal. Team BB Davis noted high incidence of lice in Hawaii because the climate makes a perfect breeding ground for these parasitic pests, so they created a safe, affordable product that destroys lice and their eggs with 100% efficiency. From Honolulu, Hawaii, please welcome Team BB Davis.
We decided to tackle a problem that is particularly important to our community, and that is head lice. There are currently no solutions available for the treatment of head lice and eggs that is effective, safe, and affordable. Why?
Lice have become almost completely resistant to the active ingredients in over-the-counter medications, such as pyrethrins and paramethrins, making these products ineffective as the CDC estimates that 98% of lice are now resistant to super lice. Prescription medications containing glindane, malathion, and ivermectin have emerged over the years. However, they are not only extremely expensive, costing up to $467 per box, but also potentially dangerous, resulting in the FDA's mandatory black box warning, advising users of all potential side effects, including death. The EPA confirmed 17 deaths associated with lindane found in pediculicides. The general public is largely unaware of these risks.
One of our own group members had a personal experience where each student in a school program had head lice except for one. And we thought that somehow this one student's hair care products were acting as a pediculicide.
First, we researched entomology. Under a microscope, we found that the operculum pops open to allow the louse to crawl out. Perhaps we could find a physical barrier to prevent the popping of the operculum. Next, we researched microbiology. For decades, scientists maintained the egg was chitinous. However, a recent study suggests that the knit and sheath could be protein-based and can contain the same 4 bands of protein that are found in the human hair. Thereby, chemical agents designed to dissolve the egg would also damage the human hair, rendering a chemical mode of action useless. We found using an H&E reagents test that the knit and sheath do contain the same 4 bands of protein that are found in the human hair, which really turned us to focusing on a physical mode of action to avoid harming the human host and to avoid resistance.
Finally, we analyzed certain hair care products, such as these, and zeroed in on 2 different main ingredients for our solution. The first one being alcohol to kill the lice, and the second one being copolymers, to turn our solution into a gel which is safer and less drippy. We thought that if we used our solution of alcohol and copolymers and covered the lice and their eggs with it, we would find that the alcohol would kill the lice while the copolymers would stop the eggs from hatching. This is because as the copolymers dry, they create a physical barrier that will block the operculum of the egg and not allow it to open.
We tested hundreds of lice and eggs in total and found that the lice that are coated with our solution had a 0% survival rate compared to the lice in our control group that had a 100% survival rate. We also found that our solution prohibited 100% of our eggs from hatching compared to the 34% of the eggs in our control group that hatched.
Why did our solution have ovicidal and pediculicidal qualities? With a sulfuric acid reagents test, we verified that the alcohol in our solution had dissolved the hydrocarbons from the cutaneous wax that surrounds the exoskeleton of the louse, allowing the alcohol to penetrate the exoskeleton to combat the lice. And additionally, to our surprise, an oxygraph test revealed that our dried solution had formed a physical barrier film surrounding the operculum, which had restricted oxygen transfer, suffocating the lice.
Our prototype cost less than $3 a bottle, and we only used 3 ingredients that are widely used in cosmetics. And the best part is, we found a physical mode of action that will not damage human hair, and the lice cannot be resistant to it.
We are really looking forward to getting our solution into the hands of as many parents as possible, and we have already started to work for schools administrators.
Thanks for listening.
All right, Team BB Davis. And as one of those parents, make sure that I send you my email address when this goes on the market, because, yeah, we've had that moment in my household too, and it's never pleasant. So I think I'm going to be one of your customers. So we've got one more STEM in Action team getting ready to come up. They are our final STEM in Action team, 9th graders from Michigan, the Whiz Kids. Those, give them a hand, go ahead. Those of you who joined us last year may recognize them. The Whiz Kids were the 8th grade national winners last year. Now that they are 9th graders, they're tackling a new community issue. The Whiz Kids are led by team advisor Dr. Gretchen Heim, and it is made up of team members Siona Bodwine, Bo Hakala, and Gabriel Poyer. Team Whiz Kids investigated removing a waste product called stamp sand from the fish spawning areas and instead using it as a base for concrete. From Lake Linden, Missouri, please welcome the Whiz Kids.
Hi, I'm Siona.
I'm Gabe. And I'm Bo.
And we're the Whiz Kids from Lake Linden Hubble High School. This represents a map of Michigan, not Missouri, and we're located here in the Upper Peninsula. In our area, there's over 500 million tons of stamp sand. Stamp sand is the waste product of historical copper mining that went on in our area and contains heavy metals. The stamp sand creates a harsh environment for plants to grow in and a poisonous ecosystem for fish. An area in our community called Buffalo Reef has a okay, I'm just gonna jump into the middle again, 'cause nerves. Okay, so can I just start over, okay. In our area, there's over 500 million tons of stamp sand. Stamp sand is the waste product of historical copper mining that went on in our area. The stamp sand was crushed and then deposited in local lakes, including Lake Superior and Torch Lake, which is located near our school. The stamp sand creates a harsh environment for plants to grow in and a poisonous ecosystem for fish. One area that the stamp sand has a large effect on is Buffalo Reef. Buffalo Reef is a local fish spawning ground that is used by the local Native American tribes. An area near Buffalo Reef has been dredged multiple times in order to get the stamp sand out of Lake Superior. Due to the winds and rain, the stamp sand keeps seeping back into the lake, which keeps on poisoning the fish. While working on our mission folder, I did the research and background information while Gabe and Bo did the procedure and data analysis. Now Gabe will discuss our data.
For our experiment, we wanted to determine whether or not stamp sand could be used as a viable fine aggregate for concrete. A typical concrete mix contains 15% Portland cement, 60% coarse and fine aggregate, and 21% water. The fine aggregate in our mixes was either commercial sand, Lake Linden stamp sand, Gay stamp sand, or a combination of commercial sand and stamp sand. Our first 3 mixes used commercial sand, Lake Linden stamp sand, and Gay stamp sand as fine aggregate. Our other 2 mixes used a combination of 50% commercial sand and 50% stamp sand, which was from Lake Linden and Gay. We first mixed all of the concrete components and poured them into cylindrical forms. After letting them cure for at least 28 days, we brought the concrete to Michigan Technological University, where we used their load frame to measure the compressive strength. The mix with the highest compressive strength was our control, or sand mix, with a strength of 4,500 psi. Our weakest mix was our Gay stamp sand mix, with a strength of 2,300 psi. All of our mixes, except for our Gay stamp sand mix, meet the strength requirements of lightweight concrete, which has a typical compressive strength of around 2,500 psi. Lightweight concrete is typically used for sidewalks and concrete walls. Now Bo will discuss our conclusions and concrete columns.
So the cylinders we tested during our experiment measured 4 inches in diameter and 8 inches in length. When the top corner broke off of the cylinder, that meant that it failed in shear. Some of the columns failed across the cross-section. This was the ideal failure method because the entire cylinder failed rather than it being localized. But shear was the typical failure mechanism for our columns. We found that both the mixes with stamp sand and sand could be used for lightweight concrete. We recommend that the gay stamp sand and sand mix be used for lightweight concrete because these sands are migrating and covering the Keweenaw Buffalo Reef and Big Trevor's Marina, as Siona stated. We estimated that if 50% of the lightweight concrete used in our area contained stamp sand, this would result in around 3,500 to 4,500 tons of stamp sand being removed from Lake Superior and its watershed annually. Using our STEM in Action grant, we'd like to look at using beach sand as the fine aggregate, testing more ratios of stamp sand and sand, along with doing outreach at local elementary schools. Thank you for listening.
The whiz kids from Michigan. You would think I would know all my state abbreviations better than that by now, but I apologize. So, let's give all of our STEM in Action grant winners one more big round of applause. That is pretty impressive. So, at this time, Mr. Frank Bond, who is one of our SME mentors this week, is going to help us out, and we're going to open it up to all of you for some questions. Who has a question for one of our STEM in Action teams? Sergeant Sanchez has a question? Oh, Sergeant Sanchez is taking questions. Frank is taking answers. Sorry. Who has a question, though? For one of the teams. Oh, right there.
On the fire device, does the actual device send the email, or does it send it to a source that sends the email out? I wasn't real clear about that, but it's fascinating.
We wrote a code to send an email basically. Yeah.
All right, what about another question? Do we have another question? No question. Oh, there's a question over there.
For the kids with the sand, what did you use to create the force to test those columns of concrete?
So we did a load frame test at a local university. It was a hydraulic press that simulated weight on the cylinders. And once it failed, it stopped applying the weight. So that's how we simulated weight being on the concrete.
Okay. How about our online friends? Do they have any questions?
Yeah, we've got a question for Brainiacs with Blue. What was your biggest challenge in coding the BioPro app?
Okay.
So our biggest challenge was that when we were coding our app for called the BioPro, the BioPro. So we were limited with 10 screens using the software that we were using. We were using the MIT App Inventor. So it limited us to only allow us to use 10 screens. So we had to consolidate with our features. So yeah.
All right. Well, these are fantastic. One more round of applause. STEM in Action. Now, at this time, we have to say goodbye to our STEM in Action teams. Bye, STEM in Action teams, because they are off to meet with the Inventors Hall of Fame, help make the world a better place. And we are going to move on with our program. But before we do that, we are going to remind everybody to do what? Oh, come on. We're going to remind everybody to vote. That's right. We need everybody to vote. NSTA donated these amazing iPads. We need to know who's going to get them. So you need to go right now. If you are on your smartphone, go to the eCYBER Mission homepage, and the button is right there to vote. If you are watching us on Ustream, you should have a button right under your viewing screen, and you can vote from there. But whatever you do, they need to what? So I'm going to make you start asking these questions because they do better with you. I don't have it. I'm not asking them right, I guess. So we are now going to get ready to hear from our next group of our teams. Our next national finalist team are the Mad Scientists. They are a 6th grade team from Illinois. They are representing the North Central region. Team Mad Scientists, they are led by team advisor Dr. Srimani Chakravarti, and they are made up of students Sia Agarwal, Mira Delore, Dia Kunin, and Unjali Sa. The team Mad Scientists observed the problem of phosphorus runoff from artificial fertilizers affecting the ecosystem of local ponds and streams, and they decided to investigate the use of natural alternatives from the existing phosphorus cycle to reduce the contribution of additional phosphorus. From Naperville, Illinois, please welcome the Mad Scientists.
So the problem that we decided to investigate was that phosphorus runoff was going into Naperville's waters coming from various sources such as artificial fertilizers and wastewater. This caused algal blooms, which takes up the oxygen in the rivers, killing the marine life and causing dead zones to form. So we set up an experiment because we wanted to find natural alternatives to artificial fertilizers in terms of phosphorus runoff and see if they would yield the same grass and soil quality.
We researched the top natural fertilizers from around the world and found that they were cow manure, goat dung, sheep dung, and coconut peat moss. Cow manure has to be composted before it is used, goat dung and sheep dung can be fresh from its source, and coconut peat moss comes from the fiber of a coconut skin. We had 2 trays per fertilizer in our experiment, and we poked 10 holes in each of these trays. We supported these trays with a Schaefer dish stand and put a bottle under each of these trays to collect our phosphorus runoff. We covered these bottles with 2 layers of tulle fabric and secured it with a rubber band so no soil will contaminate or runoff. Our independent variable in our experiment was the type of fertilizer, and the dependent variables were our phosphorus content in our runoff water and the grass and soil quality. We'd make sure we had a controlled environment in our experiment.
We started our experiment in early November by consulting an environmental specialist to make sure our design was sound. We got our goat dung and our sheep dung free from the farm, and we calculated the amount of fertilizer to use for our trays by researching the appropriate amount for a lawn and scaling it down to 1 square foot. We added our natural fertilizers into our trays as we added our grass seeds, and we added our artificial fertilizer after our grass had germinated. We watered our grass regularly, and we measured our grass height once a week. To simulate a real lawn, we also cut our grass. We sent our runoff water for phosphorus testing to the Naperville Water Department every 3 weeks.
Over a course of 15 weeks, we had a total of 5 tests. From those 5 tests, we saw that the trend was most of the results are comparable except for the low amount in sheep dung and the high amount in goat dung. Along with doing phosphorus testing, we also did grass and soil quality. So we did the RGB test, which is the greenness of the grass using Microsoft Paint. We did the root color, the root length, the soil density, the soil moisture, the soil crumbliness, the grass density, and the grass height. All the results from these tests showed no significant difference. From this, we concluded that sheep dung is a great alternative to artificial fertilizer. But another thing to take into perspective is the phosphorus cycle. So in the phosphorus cycle, 20% of the phosphorus coming into the river comes from natural fertilizers. Another 40% of it comes from wastewater, and another 40% comes from artificial fertilizer. When using natural fertilizers, we're only contributing at 20%, so we can say no to artificial fertilizers.
So part of the reason why we chose this project was because of its direct impact on the community. Naperville had received a federal ordinance from the EPA telling them to reduce the amount of phosphorus in their rivers. They actually spent over $200,000 just to clear up 10% of a lake mainly caused by phosphorus runoff.
Because of this, they've been planned to go more green by using more natural herbicides, pesticides, and fertilizers. And since our research corresponds with their green initiatives, they invited us to share it via a podcast and a board meeting. Thank you for your time.
All right, let's hear it for the mad scientists. Great job, team, great job. Okay, so while we start getting set up for our next team, are you guys as impressed as I am by the caliber of work of middle school students? I mean, every year I come to this, and every year the projects just get better and better and better, and it's just an incredible thing. And it never fails to amaze me when I compare what these kids do to, never mind what I could do in middle school, probably what I could do right now. They are just so far leaps and beyond, and just absolutely fantastic. So at this time, our next national finalist team is setting up. And our next team is Team Anks. They are 7th graders from Maryland. They are representing the Northeast region. Team Anks is led by team advisor Ravi Kumar Sisetti, and it is made up of team members Shabam Bhatnagar, Kastub Bal, Anjan Sisetti, and Neil Shah. Because pollution and global warming are growing concerns in the world today, Team Anks decided to pursue a way to reduce greenhouse gases, particularly nitrous oxide, from artificial fertilizers. Please give it up for Team Anks.
Hi, we're Team Anks. At the start of our journey, when we were looking for a community issue to solve, some issues that stuck out to us were hunger, pollution, and global warming. We contacted many farms in our local area and found that many are using cheap synthetic fertilizers, which release harmful nitrates and nitrous oxides into the environment. For example, in 1960 through 2011, U.S. farms used anywhere from 7,500 tons to 23,000 tons of synthetic fertilizers. Maryland itself is one of the largest consumers of synthetic fertilizers. In the U.S., only 0.7% of farms are organic, and of these, many are inefficient due to lack of technology in agriculture. To solve these two problems, we created the eFFE model in order to decrease pollution and increase crop productivity. The eFFE model is comprised of our tanks fertilizer and our TFA system.
Our tank's organic fertilizer is fully comprised of easy-to-find ingredients. The tank's organic fertilizer is the first part of our eFFE model. First, we created a fertilizer to help farmers find a cheap and efficient organic fertilizer. Many farmers stray away from being certified organic as they're paying more for less effective fertilizer. We believe that if we could create a fertilizer that is cheap, organic, and efficient with little to no runoff, then farmers will buy and use it. There are 3 main macronutrients the plant needs to survive: nitrogen, potassium, and phosphorus. The NPK ratio is a ratio of these 3 main macronutrients and is usually used when creating a fertilizer. After talking to many local farms, we found that the most commonly agreed upon NPK ratio was 5 to 1 to 1. Since our mung dal plants, or Vigna radiata, needed more potassium and phosphorus, we changed the ratio to about 10 to 5 to 5. Considering all this, we created our fertilizer using chicken manure for nitrogen, dried banana peels for potassium, and dried beans for phosphorus. After this, we tested our fertilizer. We tested our fertilizer against urea, miracle, and kelp powder. We found that our tank's fertilizer grew the highest and the healthiest. After this, we found the cost of our fertilizer. We found that our tank's fertilizer cost about 36 cents per pound. Although the urea only cost 21 cents per pound, our tank's organic fertilizer costed 36 cents and was organic.
As previously mentioned, one of the main concerns of modern-day agriculture is a lack of technology. That is why we have a cloud-based automation system in partnership with AWS, which consists of Arduino, Raspberry Pi, Bluetooth module, and several sensors such as a moisture, temperature, light, and pH sensor. Using Arduino, we developed a solution that took the inputs of a soil moisture sensor and sent it to a PC and compared it with the built-in threshold value of 200, and it was greater than we used our connected servo motors and a water pump to water the plants using the tube connected to a water reservoir. The tube is then controlled by our servo motors. Our Bluetooth module transmits this data to our Raspberry Pi. This microcontroller provides passageway to our AWS solution, which is comprised of our S3 bucket and EC2 instance. The S3 bucket takes all of this data and sends it to the EC2 instance. We're using Python and S3 calls booted up a web-based solution to generate a readable dashboard for farmers to easily navigate their crop data. Along with this, we used our solution to generate email alerts providing timestamp received data and a notice whenever our TFA waters our crops. We also designed a heartbeat function to get back signal whenever our device fails. Our email alerts farmers whenever the heartbeat function fails so they know if they need maintenance. This entire solution provides technology to help avoid human error and to help level up agriculture with the rest of the playing field.
Based on our results, it is proven that the tank's fertilizer performed the best because the heights of the plants that use our fertilizer had the highest mean data of 17.67 centimeters. In addition to plant height, other variables that I mentioned during our experiment were light, pH, and soil moisture in order to check if our results are being influenced by any of these factors. In the future, we would like to implement AWS GreenGlass, which is a tool that provides connectivity in remote areas. We would also like to use renewable sources of energy to power our TFA to reduce fossil fuel consumption. As for sensors, we would like to use an NPK sensor to make sure that fertilizer isn't being overutilized. We would also like to use precipitation data to make sure our TFA does not water when it is raining. Our EFFE solution strives to improve agriculture and to improve our environment. Thank you.
All right, and thank you, Team Tanks from Maryland. That was amazing. We are going to get ready now for our next national finalist team that are getting set up as we speak. Our next group of students will be coming right here from Virginia. I just remembered, I didn't even ask. Let's see, I'm trying to figure out who the furthest away, who's the team that came from the furthest away would have been. Hawaii? Yep, they went. We've got Puerto Rico. We've got Virginia. Maryland. Nobody's really excited. See, this is what happens. You don't try what? Illinois. And I don't know, I hear Texas telling me they're louder. Texas? Utah? You guys are just mellow on this side, is that it? All right, let's get ready for our next team. Our next group of national finalists is the Drone Squad. They are 8th graders from Virginia, representing the Northeast region. And they are led by team advisor Peggy Jensen, and they are made up of students Ahita Bolasetti, Ananya Karsanath, Neha Krishna, and Ananya Malapedi. And the Team Drone Squad learned through their extensive research that Americans pay over $11 billion annually for litter cleanup and decided to seek to motivate residents to clean up community litter by integrating components of modern technology. From right here in Virginia, let's hear it for the Drone Squad.
Hello everybody, we're the Drone Squad. Our names are Neha Krishna,
Ahita Bolasetti,
Ananya Kesrinath,
and Ananya Malapeti.
Our mission is to better the state of our community by motivating residents to pick up litter.
The first step for our project was to identify an issue in our society. We chose litter as it is a problem that we humans have created.
As a part of this first step, we needed to broaden our horizon of knowledge on litter. So the research that we gathered was
250 million tons of trash are found in the United States alone.
Also, $11.5 billion were spent cleaning up litter in the U.S. every year, and the 3 most commonly littered items are cigarette butts, water bottles, and plastic bags, respectively.
Secondly, we had to research the impact that litter has on the society. Litter attracts pests and rodents which carry harmful diseases, which negatively affects residents.
Also, litter results in the degradation of the nutrients in the soil, which stunts the growth of plants.
Additionally, litter harms and kills many animals.
Finally, litter creates an overall negative appearance for communities especially, and it is paid and treated for with the money from the residents.
Lastly, it was crucial for us to understand what existing help there already was to make sure our idea was unique and effective. The problem of litter has not yet been approached from a perspective other than unemphasized fines ranging from $250 to $2,500, and cleanup organizations such as Keep America Beautiful that don't have a big enough impact compared to the constant growth of litter.
The second step for our project was creating a prototype that helped eliminate the problem of litter in communities. Our prototype was constructed out of 3 components that we combined together as a group.
The first component was the drone. The drone should be able to take 20 by 20 feet pictures, upload those pictures to the program, and lastly, send GPS coordinates with each picture it takes. In the future, we hope to create a drone that can function without a remote and also reset and retake pictures for every cycle to update information.
The second component of our prototype was the program. The program should be able to identify 3 forms of litter from any spot on the 20 by 20 feet picture that the drone takes. We chose those 3 forms of litter to be plastic bags, water bottles, and cigarette butts as they were the most commonly littered items in the United States that maintained a relatively constant form. In the future, we would like to improve our program by increasing the amount of littered items identified by it to items such as food packaging.
The last component of our prototype was the app. The app should be able to display a map of the user's community, display pinpoints of where the litter is located, as well as alerting a user of nearby litter. In the future, we would like to implement a motivational reward system into our app, launch our app on the iOS App Store, and add notifications.
So we combined these 3 components together to produce the location of the litter through a map of the user's community on our app, which is called Litter.Finder. Also, the easy display of the location motivates more residents to pick up the litter.
So here are the classification accuracies for 30 samples of each litter form.
This graph shows how many times the program correctly identified each form of litter through a percentage rate. It correctly identified water bottles the least amount of times as they vary the most in form. It correctly identified them 23 times out of 30 times as it weighted the color of the water bottle too heavily, accidentally classifying them as vegetables. In the future, we would like to improve our program the most for water bottles.
And here is a graph for the fluctuation in distance between the pin drop and the litter.
This graph shows the difference between the pinpoint of the litter versus the actual location of the litter. And in the future, with a more accurate GPS system on the drone, the average distance would be reduced from 4.3 feet.
We hope our map in the app will largely impact this eco-friendly movement. Thank you so much.
Thank you. Great job, Drone Squad. So I know during our last side I was talking over here, but I'm going to come talk over here now because, I don't know, you guys were just kind of quiet and chill. So where are you guys from? What team states do I have over here? Ohio. Okay, Ohio. Anyone else here from Ohio? Go ahead, yeah, woo. You got Ohio over there. And we've got Puerto Rico. All right, and we've got North Carolina and Oklahoma. All right, so as we get ready, our next team coming up, our national finalist team, 9th graders from Massachusetts. They are representing the Northeast region, and they are Blackout. And they are led by team advisor Kelly McDonald. And the team is made up of students William Hung, Kyle Greenwood, Iltikin Wyatt, and Ayush Zenith. Team Blackout found that prolonged power outages cost Americans about $70 billion each year. And so they created a refrigerator in an effort to offset some of these losses and to protect people from foodborne illness. From West Middle School in Andover, Massachusetts, please welcome Blackout.
Hi, I'm Ayush.
I'm Will.
And I'm Ilskin, and we are Team Blackout.
Just this year alone, Andover Schools has experienced a total of 10 snow days, but not due to snow. Power outages were the cause. During these extended periods of time without access to electricity, food spoilage was a grave danger. Perishable foods can only last so long without proper refrigeration.
Each year in the U.S., approximately $70 billion is lost due to power outages, and this includes food waste and damages to structures. Eliminating food waste would save a considerable amount of money. Food stored in a closed refrigerator without power can last up to 4 hours. However, most people dispose of perishable food just to be safe. This is understandable since the risk of food spillage during a power outage is great. According to the CDC, 48 million people are affected by foodborne illnesses each year.
Our greatest concern is that people are unaware of how dangerous it may be to consume food that's been stored in an unsafe environment for too long. Seeing friends and family affected by this throughout the course of several power outages that we experienced, we decided to address this problem. Our mission was to create a reliable and inexpensive device to be installed inside a refrigerator that would alert the user when their food is no longer safe to eat.
Our engineering goal was to create a device that would alert people when their food in the refrigerator retained an unsafe temperature for a dangerous amount of time. Our basic design criteria was 1. Constantly monitor the interior temperature of the refrigerator. 2. After the temperature rose above 4 degrees Celsius, the timer would begin to measure just how long the temperature remained in this threshold. And 3. After 2 hours of unsafe temperatures, an alert via text and email would be sent and visible light on the device displayed to alert the user that their food was no longer safe to eat. Other design criteria included that the device must be affordable, it must work during a power outage, and it must be compact in order to allow maximum room in the refrigerator for food storage.
Our device was constructed using a Raspberry Pi, a temperature sensor, and most importantly, our code. The coding was the most essential part of our device. Will and Ayush had strong computer programming skills, while Iltkin and I had strong wiring and circuitry skills, and together, sharing our strengths, we were able to design and create our final prototype.
Our testing showed that our device was able to meet its basic design criteria. The device successfully sent an alert when the temperature is above 4 degrees Celsius for 2 hours. Testing includes both 2-hour testing windows and shorter trial runs to ensure more data can be collected. Alerts were consistently sent based on the monitoring of the 2 variables, temperature and time.
We as a group are committed to continuing our work with this project. We believe that our device can not only save money, but lives as well. In the future, we plan on adding a loud alarm to help notify the user when their food is no longer safe to eat. Also, we plan on making our device more compact so that it uses up less refrigeration space. And finally, we plan on looking into possible ways to maintain a sanitary environment within the refrigerator using UVC light.
Our device could have a global impact as well. In places like Puerto Rico and such, where power outages are really common, our device could provide vital information that can save people's lives. Our device, being very inexpensive, portable, can be shipped out to these areas when the need arises.
We would also like to work with engineers to implement our prototype as an adjunct to refrigerators. Most new refrigerators come with computers installed, and doing this would be a simple process. It would benefit consumers not only during power outages, but also when the refrigerator itself breaks down.
As a team, we were able to accomplish our project because we were all committed to solving our community problem. We all recognized a problem in our community, put our different strengths together, and solved it. Thank you for your time. We hope that you're excited as much as we are and are excited for the future of our product. Thank you.
All right, great job, Team Blackout. Nice work. So, I'm looking around. Raise your hand if you have a cell phone in your hand, right now. Okay, technology timeout. Everybody take a minute and tweet something using hashtag what? All right, take a minute, take a picture. It's National Selfie Day, remember? I want to see all these eCyber selfies going on. Are you tweeting? Are you voting? Oh, they're doing it. They're doing it. Gold star. I see one eCyber National selfie over here. All right, so we're going to set up for our next national finalist team. They are Gladiator 16. These are 6th graders from Tennessee, and they are representing the Southeast region. Gladiator 16 is led by team advisor Pamela Jones, and the team is Kala Kunin, Anya Cabra, Sophia Marmion, and Brennan Seltzer. Gladiator 16, through their research that cardiac arrest affects more than 350,000 people in the U.S. each year. They sought out to combat these statistics and prove that middle school students can effectively be trained in the life-saving process of CPR. From White Station Middle School in Memphis, Tennessee, please welcome Gladiator 16.
Good afternoon, everyone. We are Team Gladiator 16, and we're presenting our project on reducing deaths caused by cardiac arrest. I'm Anya, and I'll be going over the problem statement. Brennan will continue with our hypothesis. Kala will explain our methods and results, followed by Sophia, who will conclude with our community benefits. Let me begin by telling you a story of a 12-year-old girl named Gwyneth Griffin. One day, Gwyneth collapsed of a cardiac arrest at school, but unfortunately, no one around her knew how to perform CPR. By the time the rescue workers arrived, it was too late. According to the American Heart Association, or AHA, every year there are more than 360,000 cardiac arrests in the United States, and more than 90% of the victims die. A cardiac arrest occurs when the heart abruptly loses the ability to function, and that can soon turn into a life-threatening situation. A victim of cardiac arrest has little to no chance of survival unless given CPR in less than 6 minutes. Taking this into consideration, our team came up with a plan that could potentially reduce the number of lives lost because of cardiac arrest. I will now hand over the presentation to Brennan, who will explain our plan.
One of the keys to preventing deaths caused by cardiac arrest is by increasing CPR training. According to the American Heart Association and American Red Cross, only 18% of the U.S. population has current training in CPR. Amongst the school-going students, CPR training is currently offered to only high school students in some states. We believe that if this opportunity is extended to middle school students, there would be more CPR-trained individuals with an exposure at an earlier age. We interviewed cardiologists, cardiac surgeons, and nurses at Methodist Hospital and got their feedback. Based on our research, we developed this hypothesis. If middle school students are given the required CPR training, they can successfully perform CPR. I will now hand it over to Kala, who will explain our methods and results.
Thanks, Brennan. Moving forward, we decided to test this hypothesis by scheduling a CPR training session at our school. Our sample size was a group of 17 6th grade students who were trained by AHA-certified CPR trainers. Prior to the training, we pre-tested our group participants on their knowledge of cardiac arrest and CPR. Each of the participants served as their own control and test group. Before the training, only 6% of the students were aware of cardiac arrest symptoms and were confident in doing CPR. But after the training, this number improved to 100%. At the end of the training session, each student went home with an American Heart Association certificate. With this promising data, I will now turn the presentation over to Sophia, who will describe how this will benefit our community.
Thanks, Kala. Our eCYBER mission project will benefit the community in numerous different ways. Through this project, we've been able to educate and create awareness about CPR in our community. Most importantly, this project demonstrates that middle school students are fully capable of performing CPR when given the required training. Middle school students generally start babysitting at around an age of 12 or 13 years old. CPR training will help them to confidently handle medical emergencies while waiting for proper help to arrive. They can also assist others to perform CPR if needed. One of the major goals of the American Heart Association is to increase the CPR trained population from 12.3 to 20 million people by 2020. By introducing CPR training at an earlier age, we hope to contribute to this goal and prevent the loss of precious lives like that of Gwyneth Griffin. Based on our results, we propose that CPR training be offered to all middle school students. Thank you for your time, everyone.
All right,
I
great.
would especially like to thank Mr. Griffin for coming all the way here to support us with our presentation. Thank you.
Great job, Gladiator 16. Nice work. So we've heard from our first group of national finalists here, and now we want to look out into the audience and hear from you again. So we are going to see if any of you have questions for our team. Questions? No questions? I have lots of questions. Who's got a question? I'm going to come over here. I'm going to wander around until somebody has a question. I don't know. Colleen, does anyone online have a question?
Yes, we've got one. This is for Team Anks. Where are you guys? There you are. When you guys presented your products to the EPA and Amazon, what were their reaction and responses?
So when we presented our prototype to EPA when we presented our prototype to the EPA and Amazon, so for the EPA, the person that we talked to actually took our dried feed source as a phosphorus source and added it to the Montgomery County list of recommended phosphorus sources. And also when we talked to Amazon Web Services, they were very impressed by our prototype, and they also partnered with us and gave us a sponsorship for that.
Okay, great job. Oh, there's a question back there.
So for the drone squad team, I think, so I had a question, if they had a goal, if one of their goals in the future was to implement the drones to pick up litter themselves, have the drones themselves picking up the litter instead of alerting volunteers.
So the main part of our project was actually to motivate residents because we wanted to increase awareness in our community to pick up litter. So instead of like having the drones pick up litter, we wanted the residents to pick up litter. But in the future, we would have more people picking up litter by adding a motivational reward system into the app, so like younger kids can like get involved in this part of the community.
Also, when the drones go and pick up, if they do go and pick up the litter, it increases like the rate of them crashing or like getting crashed by cars. So we don't want like that money to affect the communities because we want to keep it low cost for communities.
Okay, great job. And I think we have one more question over here.
I was excited to hear about the replacements for artificial fertilizers. I just had a question for the mad scientists on how easy is it to access goat dung? Where would I get it and how much would I use?
Okay, how easy is it to access goat dung? I'm curious.
So goat dung is very easy to get. We got it fresh from the farm, and it was free. And
that was one of the things. And also for the other two natural fertilizers, the cow manure and coconut peat moss, they're really easy to get. I think they were even easier. We literally ordered them from Amazon, and they're even more cost effective than the artificial fertilizers because they cost less and you have to use less.
Fantastic. And I'm thinking, Colleen, we have another question?
I do. For Team Blackout, people want to know, different foods have different temperatures at which they spoil, so how can you tell which are still safe to eat?
Oh, there you go, Team Blackout. That's you guys.
So our spoilage alert comes after 2 hours of unsafe temperatures, and the CDC website recommends 4 hours. So what we did was we just safe-sided it. We just wanted to be safe and say 2 hours so that the user can be let know early, I guess.
Okay, great job. Great job. Oh, we've got one more I think this will be our last question in this section, but we got one more right over here. Go ahead, Sergeant Pierce.
My question is for Gladiator 16. At what age group do you think that the children in school should start learning CPR?
Well, we believe that the age group should start at whatever age you start 6th grade. We want to extend this opportunity to everyone in middle school, so it's not just high school, but everyone in middle school.
Also, we suggest students who start babysitting because at that age you might need it unless something may go wrong. So I'd say around the age of 11 or 12 is where we'd start.
Okay, fantastic. So we keep reminding people to vote, Colleen. Are they actually voting? Are they listening to us?
Yeah, people are voting already. We've already beat last year with 5,000 visits to the page and over 2,600 votes. So keep going, guys. You're doing a great job.
2,600 votes?
2,600 votes.
Ooh. So come on, everybody turn around in your chair and look right over there and say, vote! Vote! That's right. So it looks like we're time now to start with our next group of finalists. We are going to get ready to bring up Team Arrow Gals. These are 7th graders from Illinois representing the North Central region. As 6th graders, these team called themselves the Greenhouse Gals. And they competed and they won the 6th grade national title last year. So they are back, and the Arrow Gals are led by team advisor Ramu Ramachandran. And the team is made up of students Sruti Kotlo, Divya Litter, Anjana Ramachandran. Team Arrow Gals learned in their research that unpredictable weather patterns are becoming more common due to climate change and global warming. They decided to investigate a proactive rather than reactive approach, creating easily deployable safety shelters. Please join me in welcoming from Illinois, the Arrow Gals.
Hi, I'm Divya. I'm Anjana.
And I'm Shruti.
And we're the Arrow Gals. Due to climate change and global warming in our modernizing world, the trajectory, scale, and intensity of natural disasters are becoming more and more unpredictable, leaving citizens unprepared. We decided to create a disaster relief shelter modeled around a family of 4 and a dog that would be tailorable to the different regions of the United States to try and prepare citizens for different natural disasters that could occur in their community. While researching, we came across a material called aerogels, which is the skeleton of a gel with a liquid inside replaced with air. This led to further experimentation.
So for our first experiment, we wanted to test conventional building materials and see how they fared under different tests. The materials that we tested were plywood, extruded polystyrene, which is foam for all you laymen, and also 3 antitheses of cardboard. The tests that we performed were an impact test where you dropped a frozen water balloon on the material to simulate hail, a load-bearing test where you put a 15-pound load on the material, a moisture test where you soaked the material overnight and performed a load-bearing test, as well as a combustibility test where we tested burn time, self-propagation, and amount of smoke released from the material. The results from this experiment showed that none of the materials really were ideal. They all had their significant pros and cons. For example, plywood was too heavy, and extruded polystyrene, or foam, burned way too quickly. We compared our data to aerogel product data sheets, and we actually found out that aerogel did not outperform the materials in the margins we expected.
So after we realized that aerogel was lacking in categories such as load-bearing strength, we realized that we would have to try and bring this up somehow. So we took inspiration from the cardboard we researched that had corrugation in the middle and 2 skins on the outside, creating a sandwich panel-like structure. And we decided to use this to composite our other materials. We performed the same load-bearing test on these composited materials, and we realized that yes, indeed, the load-bearing strength and capacity increased tremendously.
So in our third experiment, we wanted to create our final design for our shelter. First, we brainstormed shapes that our shelter could take the form in. We brainstormed different shapes such as cubes, domes, barrel vaults, pyramids, and cones. We finally decided that the most ideal shape would be the cone, for it takes the strengths of multiple shapes into one. So for instance, it has a point and a tip at the top, just like the pyramid, so it can shed precipitation as well as resist wind uplift. It also has no particular faces that the wind can push on, just like the dome.
So our final design consisted of an innermost layer of cellulose non-toxic aerogel, an outermost layer of polyamide thin film when infused with carbon black could have fire resistance. We had 2 sheets of steel, and they could have a gap in between that could be filled with concrete if more weight was needed.
So for our community outreach, we met with Illinois state representatives such as FEMA and our local mayor and first responders. From these meetings that we learned that both of these organizations were more concerned with emergency preparedness rather than response, going back to the proactive versus reactive response. For FEMA, we learned also about their safe rooms, which are supposed to protect people in their own home. We learned that these safe rooms are actually not really used that much because they aren't very feasible, and they're actually not very friendly on the bank balance, if you know what I mean. When we met with our local mayor, we found out that he and his local first responders did not have a very good disaster response.
So along the way, we met with a lot of experts in the field, like NASA, and they gave us a bunch of samples of their aerogels that they were working on, because we realized that aerogels are being used in space, and they're actually a very widely used material, but only by the top-notch scientists like at NASA.
So in conclusion, aerogel is a unique material that is highly insulative, lightweight, and can be easily chemically modified, and when composited with other materials, can make an excellent disaster relief shelter. Thank you for listening.
Okay, great job, Team Arrow Gals. So we're going to get ready to hear from our next national finalist team. But in the meantime, did people actually do what we said and get out there and put up their selfies and start tagging things with eCYBER18?
There's certainly a lot of cheering going on, so I think so.
All right, a lot of cheering. How about in here? A lot of cheering? I know, I think I'm going to have to bring Sergeant Sanders back up at some point because, you know, just not loud enough for me. So our next national finalist team is Under Control. They are 8th graders from Ohio representing the North Central region. Under Control is led by team advisor Santosh Joshi, and it is made up of students Sohan Joshi, Pranav Krishnamurthy, and Kadar Marikarikathin. Harmful algae blooms, HABs, are a major environmental problem both in the U.S. and globally. To combat the negative effect of HBAs, Team Under Control created the Biochar Infused Floating Island, BIFI, which is made of biochar, an eco-friendly organic solid that is rich in carbon and absorbs phosphorus from the water. Please welcome Under Control.
Hello, we are Team Under Control, and I'm Kadar.
I'm Pranav. And I'm Soham. So we got started by trying to tackle a problem in the human water cycle. We came up with 10 to 15 ideas and then decided on harmful algal blooms after we realized it was a national issue. We also went on 7 field trips.
Harmful algal blooms are colonies of algae which grow out of control. They can produce extremely dangerous cyanotoxins in dead zones, which can be harmful to humans and wildlife.
They are primarily caused by an overload of nutrients from phosphorus and nitrogen, and they come from fertilizer and manure runoff.
50 out of 50 states and 15,000 lakes in the U.S. are affected by harmful algal blooms. Since 2009, the U.S. has spent over $29 billion dealing with algae-related matters.
So our solution is an eco-friendly mixture with a strong absorption ability to bond with phosphorus. This helps to prevent, mitigate, and control the blooming of algae. Next slide. So we also talked to experts including the Ohio EPA, Battelle Research Center, Ohio Environmental Council, and many more. So this is our solution. At the top we have plants, which can suck up the nitrogen in the water. We have our biochar layer, which can suck up the phosphorus in the water. On the side we have biochar pouches, because phosphorus is found not only at the top of the water body. And we have biochar briskets, which are interchangeable and can be used as fertilizer. We also got expert feedback from the Ohio EPA and Battelle Research Center, who told us our solution was feasible, but also gave us some suggestions.
We conducted extensive testing on our product with 2 different methods. We tested the effectiveness of our biochars with 3 different biochars. We found that our peanut shell biochar reduces almost 92% of the phosphorus in the water, and it can reduce around 97% after 2 weeks.
So some of the positive aspects of our solution is that the BiFi is more effective. It's eco-friendly and organic, and it's very low maintenance. It's also made out of waste products, will reduce water treatment costs and save animal deaths, also help the economy.
We have used core values throughout eCYBER mission. We have perseverance, accountability, and continuous improvement. Continuous improvement is our favorite as we use it to improve on our solution through stages of invention.
We've also filed a provisional patent on our product.
We have drafted a bill to spread awareness about HABs with Senator Chris Jordan. We plan to educate about 1 million middle and high school students in the state of Ohio. This is our final draft of our bill. August 2nd will be Harmful Algal Bloom Awareness Day in Ohio, as that was the day the Toledo algae crisis occurred in 2014. We also did community outreach on our project. We passed out flyers in our local library, did a community presentation, and even have a team website.
We've also been talking to many manufacturers and organizations to develop an accurate costing and pricing of our product.
We have talked to our local pond, the Orange Township Park Ponds, and they have agreed to let us test our solution in 2 of our ponds next month. Thank you.
All right, great job, team under control. Nicely done. So all these kids, they've got their business ventures going, they've got their solutions for the world. It just absolutely stunning. And I'm going to write all your names down so that in the future, I know which stocks to pick based on the brilliant companies formed by the eCYBER mission students this year. So our next national finalist team are 9th graders, and they are the Electro Hawks. They are from North Carolina, and they represent the Southeast region. Electro Hawks are led by team advisor Barbara Morrow, and the students on the Electro Hawks are Kayla Hooper, Hannah Hollingsworth, Demi Stomatakos, and Katie Chai. Team Electro Hawks found that some football stadiums use more than 24 million kilowatts hours per year to power their games. Rather than wasting these huge amounts of non-renewable resources, they developed a way to harness the kinetic human energy in a stadium through electromagnetic induction. Please welcome the Electro Hawks.
Here we go. Hello, we are Team Electro Hawks. I'm Kayla.
I'm Hannah.
I'm Demi.
I'm Katie. Over the past 3 years, we have developed an interest in STEM, and more specifically, the development of alternate sources of energy.
Human dependence on fossil fuels needs to be reduced because predictive models show that they will be depleted within the next century.
During our preliminary research phase, we dissected a shaker flashlight in order to further understand the process of electromagnetic induction.
When a moving magnet passes through a stationary copper coil, it disrupts its magnetic field. Small pulses of energy are generated and can be harnessed as electricity.
Being huge football fans, especially for the Carolina Panthers, we realized that these pulses can be harnessed if implemented on a grander scale.
What if we had over 70,000 people shaking the flashlights?
What if we implemented the coil magnet mechanism into stadium seats?
What if the amount of energy can be stored for later use?
Seats in stadia, auditoria, and other venues needs to harness energy through electromagnetic induction to power seats or to power advertisements, outlets, and concessions, thus reducing the stress on the electrical grid.
Before prototyping, we interviewed our physics teachers, Dr. Turner, Mr. Cook, and Ms. Fabian, in order to better understand the physical ideas behind our device.
We centered our ideas around Faraday's law.
Our teachers explained to us that using a lower gauge enameled wire would be able to withstand and produce the maximum amount of voltage.
We also interviewed Mr. Gunn, an electrical engineer at Doosan Portable Power.
In this interview, we learned that a higher gauge wire would allow for more turns in our coil without increasing the weight of our device.
To connect a gel cell battery to our device, we would like to use an isolation diode to prevent the loss of current if a part of our circuit fails.
Additionally, if we include voltage boosters in our circuit board, we can dramatically increase the energy production.
This interview with Mr. Gunn also helped us realize that we would need to implement weatherproof and childproof casings that would be accessible for repair.
Our first prototype consisted of an enameled copper coil and a magnet.
Then we wrapped our coil around a PVC pipe.
Next, in our third prototype, we printed a spool using the 3D printers in our school's fab lab.
We started with the miniature version, but the structural integrity of our design was lost when we enlarged the coils.
Then we put our coil magnet mechanism inside a laser cut seat.
We added a second coil magnet mechanism to our seat in our fifth prototype.
Our sixth and final prototype consisted of all 5 coils in an elevated position.
Finally, we used a borrowed stadium seat from the Carolina Panthers to test our prototypes.
We analyzed all prototypes with a failure mode and analysis chart. This helped us to progress each model along with our design statement and safety requirements.
Then we used an oscilloscope to further our testing, which helped us to see how the energy waves changed.
Then we conducted experiments using certain variables of Faraday's law.
Our first experiment tested the number of wire segments in each coil.
From this, we learned that increasing both the number of segments and the number of turns in our wire would increase our voltage production.
This experiment was proved further with more isolated tests on various coil turns.
We then tested various gauges to determine the optimum gauge.
Our final test compared segmented and non-segmented wire and determined that both methods produce the same amount of voltage.
Our device would be beneficial to our community because in developed countries where large-scale stadia are present, otherwise wasted kinetic energy can be harnessed as a viable energy source.
While one seat produces only 3 volts of electricity, 70,000 seats connected together in series can produce around 2.4 million volts of electricity.
Thank you.
All right, great job, Team Electro Hawks. Nice work. So we're going to get ready for our next national finalist team. We are going to move back into the 6th grade. And our next group are Squeegee Fest. Oh, I am sorry. Squeegee Feast. Okay. Yeah, nope, I got that one. It's all the M's, I know, I'm sorry. So our next finalist team is going to be Squeegee Feast. They are 6th graders. They are from Mississippi. They are representing the South. Okay, go ahead. This is awesome. They are representing the South Central region, and they are led by team advisor Ashley Klein. And the team is made up of Lillian Bogan, Andrew Doherty, Carrington Fowler, and William Fugit. After a particularly bad flu season in their school, Team Squeegee Feast determined that a new cleaning system was necessary to help prevent illness, so they created one. From St. Richard's Catholic School in Jackson, Mississippi, please welcome Squeegee Feast.
Good afternoon. My name is Carrington.
I'm Andrew.
I'm Lillian.
And I'm William.
And we are Team Squeegee Feast. Together, we built a cleaning mechanism that we like to call the squash. Originally, our inspiration came from our dislike of always having to clean the cafeteria. But after our school was hit particularly hard during the 2017-2018 flu season, we realized that we could build something with other benefits in our community as well.
Some of these benefits are, it can clean tabletops and all the flat surfaces, it can reduce the spread of germs, it can keep kids in school and parents at work by producing a cleaner environment, which means they have a less likely chance to get sick. It can have use in military use in remote locations where other resources may be lacking. It can have use in the medical environment enhancing cleanliness. For our project, we set design goals. Some of these design goals were it needed to clean solids, liquids, sticky residues, and germs. It needs to be easy to use, portable and lightweight, low cost, automated, and of course, always safe.
To begin the build process, we gathered supplies from what we had on hand and purchased a UV light to disinfect the surface that we wanted cleaned. But first, we developed our design sketches and eventually came up with the design that we have now. The UV light separates us from other cleaning products that don't have a light that sanitizes the surface. We gathered supplies and we started constructing the squash. We had the help of adults when using power tools for safety reasons, but they still worked under our instruction. Later on in the build process, we had to modify the drive mechanism after the squash had been tampered with, and we added Gorilla Tape to the axles to keep the belt from falling off during testing. The parts of the squash are the frame, the drive mechanism, which includes the wheels, the axles, the belt, and the Gorilla Tape. In the center, we have the cleaning receptacle that collects our solids. We have the cleaning paddle with 2 sponges and 2 wiper blades to collect the liquids. We have the UV light in the back with a shield for safety. The shield also reflects light back onto the table. I'm about to demonstrate how the squash works now.
To test the squash, we covered the tables with different substances we normally find in our cafeteria. This includes animal crackers, different crumbs such as salt and pepper, lemonade, fruit juice, matcha, ketchup, mustard, germs, and other substances. To find the percentage clean for the solids, we did a particle count before and after testing the squash. Now this was the worst part, because you had to count every single grain of salt and pepper. So we were like 1, 2, 3, wait, have I counted this already? To find the percentage clean for the liquids and sticky residues, we counted the amount of splotches before and after testing the squash. To find the percentage clean for the germs, we swabbed the tables before and after testing the squash. Then we took the samples and wiped them in blood agar and waited 3 days. After this, we determined the percentage cleaned by comparing the amount of colonies before and after.
The squash performed very well in tests, better than we had hoped. But as with anything, improvements could have been made. If we had had more time and more resources, we would have built the squash using sturdier materials, such as plastics and metals, to make it more durable. We also would have added a gearbox because it was a little too fast during the tests for our liking. We would have made the cleaning receptacle as well as the paddle removable so that they would be easier to clean. Thank you for watching our presentation. We hope you have enjoyed.
All right, great job, Squeegee Feast. Now I'm curious though, the people in the back cheering, are those the grown-ups who worked for you?
Yes. Yes, they are.
Were you a kind boss, or?
Yes.
Yeah? They treated you well? They were good bosses? That's awesome. Don't ever explain to my children how to make me work for them. I know my children, they would not be so kind. So we've got another national finalist team coming up, and they are the Ecstatic Statistics. They are 7th graders from Alabama. Did I get that one wrong? Oh my goodness. I was so worried about all the S's that they are the Ecstatic Statics from 7th grade in Alabama, representing the Southeast region. The Ecstatic Statics are led by team advisor Bina Chopade, and the team is made up of students Naiha Chopade, Pooja Chopade, and Pranav Samu. The batteries are bulky, expensive, harmful to the environment if not discarded properly, and Team Ecstatic Statics endeavored to find a solution to this problem by using the triboelectric effect to generate usable electricity while on the move. From Madison, please welcome the Ecstatic Statics.
Static electricity is typically portrayed as an unwanted force that messes up your hair or zaps you in the winter. We are Team Ecstatic Statics, and we have innovated a new device that can harness static electricity to provide millions of people with usable electricity from simple everyday motion. Over the past decade, personal electronic devices have become ubiquitous. Finding a new way to power them is an important issue, especially for people on the go, where access to electricity is limited. Additionally, soldiers in the U.S. Armed Forces carry about 20 pounds of batteries during remote missions. We wanted to build an eco-friendly, lightweight device that could efficiently power personal devices while promoting exercise.
Our triboelectric nanogenerator, or TENG, T-E-N-G, is a novel device that harnesses such static electricity in a usable form. We utilize triboelectricity enhanced by nanotechnology in our solution. When two different materials of opposite triboelectric charges come in contact with each other, electrons transfer from the positive to the negative material. This creates a potential difference, and when the materials are connected through an external circuit, electrons flow, which generates electricity.
First, we did a proof of concept experiment using mini tanks made from wooden blocks. We tried out various combinations of materials and measured the electricity output with a multimeter. The most efficient combination was Teflon and aluminum. Next came the innovative grading design of the electrodes that maximizes the efficiency of our device. Since Teflon is non-conductive, we used two aluminum electrodes paired with complementary Teflon electrodes that simply transferred electrons from one electrode to the next. This was achieved by placing aluminum strips on an acrylic board and connecting alternate strips to make a series of electrodes.
We used a bridge rectifier circuit, which consists of an arrangement of diodes, to convert the alternating current into direct current. This charges a capacitor, which can then be used to power other electronic devices. Our tank harnessed enough electricity to light up an LED.
The next step is to increase the efficiency of our device. Our research showed that modifying the surfaces at nanoscale would significantly increase electricity generation. Our attempts for this, however, were not successful due to lack of access of necessary nanotechnology. We were able to modify the surfaces at microscale using different grades of micron sandpaper. We tried 0.3, 1, and 5 micron grids. After testing, we concluded that 0.3 micron grid sandpaper worked the best. We performed each experiment 3 times to collect reliable data and to get a measure of potential error. Our data analysis showed that as the surface modification scale is reduced, the electricity output would exponentially increase. If we were able to gain access to the technology needed to modify the electrodes at the nanoscale, we would see a substantial increase in the electricity output of our device.
Finally, we created a functioning device. We built 2 frames for it out of Lego Technic bricks and fastened them along axles so they can side against one another. Each frame consists of 1 triboelectric material. Our simple, lightweight device converts vertical oscillation motions, such as those created by walking, into usable electricity.
We successfully demonstrated the concept of the Tang, built a working device that can harness static electricity, created a way to power portable electronic devices, and made a potential solution to replace heavy batteries used by the U.S. Armed Forces in the future. Next time you feel static, be ecstatic!
Great job, team of Static Statics. So we've had another group, and it's time to do another Q&A, but this time, I'm asking questions. So let's see, do we have a microphone? Oh, you're gonna be our microphone. So let's see, I wanna know who had a favorite thing so far this week from the students. Who had a favorite thing? Go ahead, what was your favorite thing?
My favorite thing was going to Washington, D.C. and getting to meet all my team, like all the people that we're going against, because they're all so nice.
Oh, awesome. Who else had a favorite thing this week? Yes.
Also on DC Day when we got like ice cream a bunch of times, that was really great.
Ice cream a bunch of times. Wow, I didn't even get ice cream one time on DC Day. You got a bunch of times. Right over there.
I enjoyed learning new things in the lab stations and the lab activities, making new friends from different states all over the place. That was fun.
Awesome. How about anybody over here? You have a favorite thing? You guys are still mellow over here. Favorite thing this week? Nobody. Okay, over there.
So as a TA, I really enjoyed the chance to meet with a lot of great minds, both other TAs and those who, the soldiers and those who, the scientists and everyone who helped out. And I enjoyed watching not only my own students, but all the students here grow academically and in competence. I mean, invaluable.
Absolutely. So do we have any new and interesting comments coming up, Colleen?
We sure do. Steve would like to know what inspired you to create your device, Electrohawks?
All right, so where are the Electrohawks? Up over there.
Our school places a large emphasis on composting and recycling, so we decided to expand this to to help reduce the usage of non-renewable resources.
And to add on from that, we in the past competed in MIT grant and previous eCYBER mission, and so we decided to recycle the knowledge that we already had into this previous project. So, yeah.
Okay. All right. Do we have another question from our online friends?
We've got one for Aero Gals. About how long would a family be able to survive in your safety shelter during a natural disaster?
The shelter is not made for long residence. It's supposed to last for the duration of the disaster. But any family that is thinking of living in there long term, buy a house. It's not going to be very comfortable to live in there your whole life, but it will keep you safe from most disasters.
Outstanding. So before we go on to our next group of students, I have a very important announcement for everybody. In case you had forgotten, everybody needs to what? You need to vote. You need to vote. Are they voting?
They are voting. I just got word we are over 4,500 votes now.
4,500 votes.
Keep voting.
Keep voting. So this is all getting pretty exciting. People are checking in. People are making decisions. You want to know what my favorite part of the week is? This. This is my very favorite part of the week because this is the one time during the week that I get to see all your projects, and I look forward to this part of the week every single year. So with that, we are going to move on to our next set of projects. I am going to turn my page. So our next national finalist team is Team Agua Rico. They are 8th graders from Puerto Rico, and they are representing the Southeast region. Team Agua Rico is led by team advisor Ingrid Rapids Rutger and is made up of students Janelis Guzman Acevedo, Dan Ellsworth Babylonia, Gianfranco Orma Ramirez, and Bria Rutger. After Hurricane Maria devastated Puerto Rico, Team Agua Rico learned firsthand the hazards of drinking contaminated water. So to tackle this crisis, they set out to create a way to filter water and make it safe for consumption. From Rami School in Aguadilla, Puerto Rico, please welcome Team Agua Rico.
Bienvenidos.
Welcome. My name is Gianfranco Rama.
Janelis Guzman.
Dan Ellsworth.
And Bria Rector.
And we are Agua Rico. Imagine being stranded on an island without available drinking water.
On September 20, 2017, Hurricane Maria devastated Puerto Rico. It left millions without reliable water, electricity, or communication.
Our team identified the issue of water contamination during the aftermath of Hurricane Maria. After taking a survey which showed 83% of the students at Ramey had running water, though most of the water was contaminated due to lack of electricity.
These victims were required to take desperate measures to gain food or drinking water from hazardous, unsafe sources such as rivers or rooftops. This led to the spread of bacteria-related diseases such as leptospirosis, which can be common in many water sources.
All of our team members experienced the struggle of getting reliable potable water. Based on these events, our team confirmed the urgency of this problem and are motivated to find a possible solution for our local community.
Water contamination is not a new issue in Puerto Rico. Even before the hurricane, the Washington Examiner referred the island as the most contaminated water in the United States. Water contamination is a critical issue that many Puerto Ricans suffer, especially after Hurricane Maria.
After identifying this issue, our team developed a design statement which reads, "How can we prevent bacteria-related diseases through water contamination during the aftermath of Hurricane Maria?"
After creating our problem statement, we made inferences, observations, and predictions to produce our hypothesis, which reads, if we filter contaminated water using a modified solar water distiller and secondary filtration device, then the output water quality will be purified and safe for consumption.
Our team later developed a list of roles and responsibilities based on each team member's strengths to ensure that all aspects of our project were completed to its fullest potential.
Our team researched our topic through websites, articles, interviews, books, and presentations. The subject matter includes Drew Cosso and Ruby Rivera, biologists and conservationists who work for Rich Tarif, science and computer teachers at Ramey Unit School, David Sasser, civil engineer, and Steve Tamar, a microbiologist.
Our team also researched information related to the local water contamination issues, types of diseases carried through contaminated water, the Oaxaca Reservoir, resources brought to Puerto Rico for the relief effort, and local and natural resources found around the island.
Our team constructed 2 different prototypes with natural resources that were accessible to residents in Puerto Rico, such as coconut charcoal, husk, and sand.
We also implemented materials that were common in everyday households, such as 5-gallon buckets, PVC pipes, copper tubing, screen, mesh, and coffee filters.
After constructing our various prototypes from water devices and tested each water sample using 2 reagents to test for E. coli, enterococci, and conform bacteria, and then used probes and other devices to test for dissolved oxygen, conductivity, pH, and temperature.
We then studied the EPA levels for safe drinking water to set a criteria for the results of our water test.
The results of our first test included running tap water and irrigation water through our device, which resulted in high levels of enterococci, E. coli, and coliform bacteria.
Our second prototype included sterilizing all our filtration materials, sand, husk, and coconut charcoal, and transferring them to one 5-gallon plastic bucket. The results demonstrated that we were able to reduce the number of coliforms and E. coli to 0, but still have traces of enterococci.
Our final test was conducted by using 4 different filters that we created. According to the table, the sand husk and regular charcoal reduces all contaminants to 0 and maintains EPA levels safe for drinking water.
We displayed our data through graphing each filter result on a scatter plot or graph to display how effectively our device filtered against E. coli, enterococci, and coliform bacteria.
According to the results, not only did we manage to prove each device was each trial, we were also able to succeed in eliminating all E. coli, enterococci, and coliform bacteria from both city and irrigation water samples.
This means that we reached our goal and support a hypothesis of developing an effective filtration and decontamination device using natural resources.
By simply empowering people to build their own filter, Agua Rica could possibly reduce the number of deaths and illnesses from the consumption of contaminated water.
Since resources that were used to construct the Agua Rica distillation filtration device were widely available to Puerto Rico, then the production and distribution of it would be more reliable than other commercial filters.
In the future, we would like to modify our Agua Rica filtration device by applying silver-infused ceramic within it.
We would also like to modify the distillation section of our filter to verify that it can be used effectively to filter contaminated water.
In addition, our team would like to educate our community about the ADFD not to construct one for their own personal use.
Thank you.
All right. Great job, Team Agua Rico from Puerto Rico. Nice job. So we're getting down to it. We've only got a few more teams left. So next coming up will be our nationalist finalist team from New Mexico representing the South Central region. They are the Memory Tigers. The Memory Tigers are led by team advisor Laura Tenario, and the team is made up of students Brittany Sue, Abdul Qais, Michaela Martinez, and the Memory Tigers have investigated the natural remedies found in Chinese and Hispanic cultures that have a lower rate of neurodegenerative diseases like Alzheimer's and Parkinson's to produce a medicine that has the potential to reduce amyloidosis and the accompanying disorders. From Taos Tiger Lab in Taos, New Mexico, please welcome the Memory Tigers.
Hello everyone, my name is Abdul Qais.
Hello, my name is Michaela Martinez. And I'm Brittany Sue. Memories are the cornerstone of our identity. Our experiences help shape who we are and help us guide our future. Actions are the expression of how we are able to interact with and impact the future. The food we eat has an impact and shapes the future of how we function.
Neurodegenerative disease destroys memories, muscle movement, synapses, and the ability for the human body to function properly. Alzheimer's is the worst, as it starts out stealing your memories and finishes by stealing your life. Research studies have indicated that type 2 diabetes is related with amyloid plaques associated with neurodegenerative disease labeled as type 3 diabetes.
I have type 1 diabetes and I want to see a cure. When we developed this idea, we started out with the past, our families, and how certain cultural remedies have been proven to reduce diabetes. We noticed we're a very multicultural group. Chinese,
Arabic,
Hispanic. We are from cultures that have a history of producing individuals with long lives, who have a history of producing individuals with a history of
who share a history of long storytelling through cultural remedies. We found the connection between diabetes, neurodegenerative diseases, and the protein that causes them, and used and culturally collaborated to research remedies associated with memory preservation, lowering stroke risk, and having the least side effects on the rest of the body. This produced capsaicin extracted from habanero peppers, goji berry, cinnamon, gota, and turmeric as testing media.
We also had to find a viable alternative to human testing. C. elegans, or soil nematodes, can be adapted by synthetically produced insulin to produce high levels of amyloids. While scientists have used genetic adaptations to produce these transgenic C. elegans, we decided to do a small experiment with insulin introduced to the C. elegans food supply to induce amyloidosis.
Amyloidosis is a hyperproduction of amyloids. By experimenting with the C. elegans and varying concentration of synthetic insulin, we thought we would take 5 generations of offspring to produce amyloidosis. The amyloid protein, as indicated by 1% dilution of Congo red, as introduced to the C. elegans environment, began to appear within high rates within 2 generations.
We used 1% extractions of distilled water and the remedies and introduced them to pre-insulin exposed and post-exposure and monitored the color change as the Congo red bonded to the proteins under a microscope set at 4 to 10x. We also monitored the amount of plaque buildup, color change, morphology, and metabolism over a series of 10 subjects over time.
Turmeric was the leading suggested natural remedy in many Alzheimer's studies, but it was 40% less effective in preventing and reducing amyloid production. Capsaicin and goji berry were both approximately 90% effective at preventing and reducing amyloid production and plaque buildup with a 90% survival rate. Kota and cinnamon also had an impact in preventing and reducing amyloid production and plaque buildup, but not as significant as the capsaicin and goji berry.
Samples untreated with the solutions had a nearly complete mortality and fast amyloidosis. We also did samples without Congo red because it accelerated mortality rates. The protein production was visible without it, breaking up through the presence of capsaicin and goji berry.
We happened to use the habanero pepper, which is of a different family of chili peppers as it is Capsicum chianese rather than Capsicum annum. Goji berry is also of the chianese group, indicating that this family has antioxidants and other chemical properties that break down the plaque adhesion structure. This has the potential of being an amyloid plaque reduction agent that could reduce neurodegenerative disease and diabetes in the future.
Shukran.
Yes, yeah.
Gracias.
Thank you.
Great job, Teen Memory Tigers. That was fantastic. So our next finalist team, they are the Purple Bananas. And they are 6th graders from Utah representing the West region. The Purple Bananas are led by their team advisor, Jenny McIntosh. And the team is made up of students Brighton Farnsworth, Titi and Soha Masejas, and Gage Nichols. The team Purple Bananas learned that more than 1.1 billion people in the world do not have access to batteries or electricity, meaning no light source after the sun went down. So they explored an alternative energy solution and created a thermoelectric flashlight that runs on body heat rather than a non-renewable source. From Draper, Utah, please welcome the Purple Bananas.
Hi, my name is Titi.
I'm Gage. And I'm Brighton. And we are the Purple Bananas. For our science fair project, we created a thermoelectric flashlight. A thermoelectric flashlight is built out of Peltier tiles and runs on body heat. Body heat can be used as an alternative source of energy and is more environmentally friendly than batteries. Now, you may be asking, what's a Peltier tile? A Peltier tile is a tile with the outsides are made of ceramic and the inside is a combination of 2 metals. One is unknown and one is bismuth. On our board, you can see what a Peltier tile looks like on the inside. So basically, when one side gets really hot and one side gets really cold, the thermal energy courses through the metals and meets at a melting point. It then goes through a wire and through a voltage booster. Without a voltage booster, the 2 Peltier tiles create half a volt. With the voltage booster, they create 9.68 volts, which is plenty enough for the LED to light up.
Our problem statement was, how does the ambient temperature affect the brightness of our thermoelectric heat-powered flashlight?
So we are going to build a thermoelectric flashlight that is built out of Peltier tiles. This flashlight is designed for people in third world countries who don't have access to batteries or electricity. So if we can harness enough energy from Peltier tiles to build a heat-powered flashlight, then it will work better in colder temperatures.
This is due to the fact that the greater the temperature difference between the two sides of the tiles, the more electricity is produced.
Our independent variable was the different environment temperatures. Our dependent variable was the brightness of the bulb. Our controlled variables were the same hand, the same person, the same flashlight, and we conducted the experiment on the same day.
As you can see in our graphs, the cold temperatures worked the best with the flashlight. In 36 degrees, it got over 40 lux and lasted 17 minutes. This was only using one hand. In room temperature, about 69 degrees Fahrenheit, it did not work as well, shine as bright, or last as long.
In the 85-degree temperatures, it did not work as well and it dropped dramatically. And in the 90-degree temperatures, it did not work at all.
Our community benefit was, in our global community, 1.1 billion people do not have access to reliable and clean energy sources. And by creating this flashlight, we are solving that problem.
Okay, so we went to our local American Red Cross and we asked if these could be used in relief packages after natural disasters. Because most people after disaster strikes, they still have to go to work in the morning, go to their job, and then they come out and clean their houses out at night. Well, at night, it's always cooler and it's dark, so you need a flashlight. And since our flashlight works better in colder temperatures, she said, the lady that we met with at the Red Cross said that they could be used in relief packages, and if we were to further our project, we would look into that.
Some improvements that we can make to this flashlight are taking off the aluminum tape on the front of the flashlight. This would increase the airflow through the flashlight, making the side of the tile cooler, the side of the tile that needs to be cold cooler. We could also insert a bigger aluminum heat sink that would eliminate the heat better.
We learned that we can make a thermoelectric flashlight light up brighter and last longer as the temperature gets colder. When we switch hands, the flashlight could last even longer. We learned that cardboard, the material we made our flashlight out of, works the best because it is hollow, like a sandwich, and allows for more airflow, thus making the flashlight cooler and producing more electricity.
In conclusion, our flashlight worked even better than expected. If we were to retest our hypothesis, we would take out the aluminum tape for more airflow.
Thank you.
Okay, so we're coming down to it. I think we've got 4 teams left. And the next one of our teams are the nationalist finalists from Texas, representing the South Central region. They are the Cricketeers. They are 7th graders, and they are led by team advisor Laura Wilbanks. And the Cricketeers are made up of students Brennan Morton, Garrett Nelson, Gary Regner, and Caden West. Solving world hunger is a global issue that Team Cricketeers believes requires immediate action. To this end, they work to identify a sustainable food source that provides densely packed nutrients but uses less water, less processing, and less land to produce. From Southcrest Christian School in Lubbock, Texas, please welcome the Cricketeers.
Good afternoon, everybody. My name is Garrett Nelson. This is Brennan Morton, Gary Regner, and Caden West. Millions of people die of malnourishment every year, and hunger is arguably the most important problem in our world today. The challenge of global food security is great. By the year 2050, Earth's projected population will be 9 billion, and the demand for food will increase by 60%.
With current land and water issues, only half the world population could be fed by the year 2050. There are 3 key goals of feeding a growing world is to become a reality. 1, use sustainable agriculture. 2, improve nutrition worldwide. And 3, achieve food security for the most vulnerable population, children.
Learning that 66 million children are affected by hunger, we want to take part in a solution not because we are hungry, but because we have never truly been hungry in our lives. Our goal was to identify a sustainable food source for those locally and those in other countries. We want to fill the gap between those who have food and those that are hungry.
Extensive research was conducted using multiple resources and perspectives to get a balanced view of the issue. Community collaboration with industry and nonprofits began, which led us to identify the perfect solution: insect and plant-based proteins. Plants such as lentils and triticale that grow on my grandfather's farm proved to be excellent sources of protein. They also appeal to a wide range of palates around the world, meaning they could be incorporated into existing foods more easily.
Insects should also be protein rich, and although not widely accepted as a food source in America, are eaten in other parts of the world. There were 3 key questions that we had during this process. Which insect should we use? Which insect was the most sustainable? And which insect was the most accessible?
A variety of insects were considered, but the team maintained a habitat of crickets, and they proved to be the insect that thrived. We also worked with a local termite expert to gather these because they had both protein and high fat for brain development.
4 hypotheses and experiments written. First, testing protein qualitatively using a bioret solution. Next, figuring out insect fat content using Sudin-3 dye. Third, using a spectrophotometer to quantitatively analyze protein data in crickets, grasshoppers, and silkworms. And finally, determining moisture content in protein cookies made with crickets.
The results of the protein testing showed grasshoppers, termites, and crickets to be the highest. Fat content was highest in mealworms, followed by termites, and then crickets. Considering the sustainability of each insect, along with the results of the fat and protein testing, the decision was made to use crickets as a food source.
We then ground the crickets into a flour we used to make a protein cookie we called the Cricketeer cookie. It was densely packed with nutrition and, believe it or not, extremely delicious. To make sure it could be packed and distributed safely, we underwent moisture content testing, and it was a success. We then worked with Breedlove Foods, the largest nonprofit food aid distributor in the world.
We're fortunate to have this partnership. This summer, our first shipment of cookies will feed over 100 children in the Hannah Orphanage in Bangalore, India. Other communities outreach include a website, pledges to eat meatless, and speaking to groups about the responsibility of sustainable agriculture through plants and insects.
Packaged nutrition provides a temporary solution for those malnourished. In the future, insect farms can be established. This would then give the people an opportunity to benefit from sustainable agriculture. And thank you.
Thank you. Great job, great job. And you know what? I actually got to taste a cookie yesterday. And they caught me like in that weak moment when like I didn't get to eat lunch and dinner wasn't for like another 45 minutes. And they're like, here, a cricket cookie. And I was kind of like, all right. No, it was really good. It tasted, I wouldn't have known it was a cricket cookie. It was chocolate chippy and it was awesome. So I can't speak to the science, but good cooking. So we're coming up on it now. Wow, a cheering section. We've got our next national finalist team, and they are Hemophilia Hope. They are 8th graders from Oklahoma, representing the South Central region. Hemophilia Hope is led by team advisor Jason Arendt and is made up of students Chance Annis, Maggie Edwards, April Sims, and Jenna Tuggle. Hemophilia, a genetic blood disorder that inhibits the clotting of blood, affects more than 20,000 Americans, one of whom is the friend and classmate of Team Hemophilia Hope. The team aspired to create a sleeve to help people with hemophilia worry less about bruising and bleeding so they could focus more on enjoying life. From Oklahoma, please welcome Hemophilia Hope.
Hello, my name is Chance.
My name's Maggie.
I'm April.
I'm Jenna. I'm thinking of a number between 1 and 4,999. I want you to try to guess this number. Seems almost impossible, right? But what if I told you you have more of a likely chance of guessing the number I'm thinking of than being diagnosed with this blood clotting disorder known as hemophilia A? As rare as this is, we actually have a close friend and classmate of ours that was diagnosed with hemophilia A at a young age. So us being close friends of his wanted to make him and other people with hemophilia a sleeve that would protect them from a fatal cut or bruise, allowing them to live a more carefree and athletic life.
During this process, there were many different things that we did to work together well as a team. One thing we did was to have specific jobs for each person so no one would be off task. We also had a timeline, so each day when we came in to do eCyber, we wouldn't have to spend extra time trying to figure out what we would be doing for that day because we already had it pre-planned.
The engineering design process was very critical to our project. We used this process step by step along the way. For example, our first prototype, we used a padding called packaging foam, and later on learned it wasn't durable enough to sew into our sleeve. So we went back to our data and researched, and then the second best padding to use for our sleeve was a padding called eCYBER18. But overall, our team learned the engineering design process was very important in completing our mission.
Before our mission began, we knew we wanted to create a sleeve, and with that sleeve, we needed padding. We discovered sorbothane, alpha gel, and packaging foam. The apple drop test allowed us to test each of these paddings to see which would be best for our sleeve. We laid our paddings out on the floor and dropped apples from 3 different heights, 4, 6, and 8 feet. We chose to drop apples because of their tendency to bruise. After 24 hours, we checked our apples and measured the surface area of each bruise. We noticed that the packaging foam did the best in all 3 drops. However, packaging foam just isn't durable enough for our sleeve. So we ended up moving over to sorbothane, which is a lot more durable and disperses impact very, very well. Sorbothane also did better than the alpha gel in the 4-foot drop. Therefore, we chose sorbothane as our padding. The second test we did was the sander test. This really tested the durability of our sleeve in realistic conditions. We took a sander and rubbed it all over our sleeve. We also took some rocks and scissors and scratched up our sleeve that way too. After the test was complete, we saw that our sleeve was very, very durable, and we were so happy with the results we got.
Today I want to talk about struggles, difficulties, and changes I'd like to make in the future. One struggle we had during our eCyBER mission process was finding a good quality sewing machine to sew our thick and dense padding to our sleeve. Another struggle we had was with the apple drop test. It took us a few times to correctly measure the surface area of each bruise so we can use it in our apple drop test graph. Here are some things we'd like to change in the future. We would like to add Velcro. Velcro would allow the user to put on the sleeve and remove the sleeve easier, and it would fit all arm sizes. We'd also like to improve our sander test. The sander test only collected qualitative data, not quantitative data, so we were unable to make charts or graphs. So in the future, we'll collect quantitative data so we make charts and graphs to better understand our strengths and weaknesses within our sleeve. We would also remove the ballistic nylon. Ballistic nylon is not flexible or breathable.
In conclusion, our project was a race of dips and turns which almost caused us to slide off the track, but we were able to get back on and finish with a strong lead ahead. We are so happy to have the privilege to make a difference for people with hemophilia all across the world. And as the natives in Africa would say, eCYBER hon anin, eCYBER hon, which means if you want to go fast, go alone, but if you want to go far, go together. Thank you.
Whoa, well done. All right, so we're going to get ready to bring up our next nationalist finalist team, and they are the Westview Wildcats. They are 9th graders from Oregon representing the West region. The Westview Wildcats are led by team advisor Anath Sankuranarayanan and made up of students Manasa Pulavarti, Shruti Ananth, Trithka Bishop, and Maria Kolatakudi. Medication is often used after a panic attack occurs. The Westview Wildcats sought a way to help during the attack and created a device to alert the wearer and bystanders of the occurrence of a panic attack. From STEM for Girls in Portland, Oregon, please welcome Westview Wildcats.
Hi, we are the Westview Wildcats, and today we will be explaining the importance and over 6-month creation process of the Panic Attack Warning System, or PAWS. Last year, all of us had an eye-opening experience regarding the very real effects of panic attacks. One of our close friends had suffered from a panic attack episode, and although we were right there, it felt as if there was nothing that we could do in the moment to help her through the immediate trauma. After further research, we learned that over 6 million Americans suffer from panic attack disorders just like our friend, and this number is expected to increase by 20% by 2050. A panic attack is a sudden episode of intense fear that triggers severe reactions when there is no real danger or cause. Some of these symptoms include increased heart rate, sweating, and shivering. A panic attack has the potential to completely change the direction of someone's life, simply because research regarding mental illness is pushed to the curb too often. We wanted to take the first steps to change this reality by using the power of STEM.
Concerned with the effects of panic attacks, we wanted to come up with a way to minimize these effects on our community. We continued our engineering process by researching current solutions that are readily available to patients today. We learned that the only existing solutions are medications such as beta blockers and serotonin, and psychotherapy, a form of talk therapy used to help the patient come to terms with their disorder. We learned that there are no solutions that help a patient during the episode of a panic attack. Based on this revelation, we were motivated to come up with and answer the question, how can we reduce the intensity and duration of panic attacks using sensors in a cost-effective manner? This resulted in our device, the Panic Attack Warning System. The goal of PAWS is to create a prototype that proves that we can use sensors to detect the occurring symptoms of a panic attack and then alert the user. By detecting a panic attack before it reaches its peak, we alert the user and help them understand that they aren't in danger, which in turn helps them to regain their breathing.
There are several symptoms that are associated with panic attacks. We researched them using multiple medical sources, including PhysioNet, PubMed, and various experts in the field. After our extensive research, we chose 3 sensors to measure the heart rate, sweat levels, and shivering, and we connected these sensors to an Arduino microcontroller, creating the skeleton of our device. We were able to produce PAWS for under $250, and through further testing, we believe that we can continue to lower the cost. Now, we will be demonstrating our device. We used Python and Arduino to program our device. Our device runs the program that displays the sensor values on this screen and turns this buzzer on when the sensor values exceed the predefined thresholds. The user can then turn off the buzzer by pressing this button.
After extensive data collection for the various age groups, our data showed that our prototype is able to collect sensor data to ensure that all of the tested symptoms are underneath the threshold values. And this can be seen in the enlarged graph. Throughout this competition, we were in collaboration with many different experts, such as Dr. Serum from Britain, Dr. Quinn, and many other experts from the Veterans Affairs in Vancouver, Washington. Overall, they were very impressed by our product and truly believe that this will not only help patients during a panic attack, but also help them go through the acceptance process for their disorder. So for the future, we would like to make our device more user-friendly and easier to wear. To do so, we have already contacted Jawbone, a fitness tracker company who already has the sensors which we need. We will also create an app that will store crucial information such as location, time, and sensor values. We would also like to create personalized thresholds so that this could be more efficient for everyone. In our society, there is a negative stigma around panic disorders. With our device, we are not only helping the community members, but also the 6 million patients not only accept their disorder, but also helps them through this traumatic experience. Thank you for your time.
All right, great job, Wildcats. All right, this is about it. Our final finalists, our last team. So we are going to bring them up, and they are Team Absolute Zero. They are 8th graders from Utah representing the West region. Team Absolute Zero is led by team advisor Rebecca Kern, and the team is made up of students Isabel Crofts, Lily Crofts, and Nithya Mahasenan. Team Absolute Zero aims to eliminate the water shortage crisis throughout the world by creating a safe, inexpensive, durable, and reusable water filter out of simple materials and methods. From Draper, Utah, please welcome Absolute Zero.
Good afternoon. Our project is Absolute Zero, and we're from Draper, Utah. Just to let you know, the link right there is for our website, so feel free to check it out during our presentation. I'm Nithya.
I'm Lily, and it was feeling kind of tense in here, so I'm going to give you a science joke. What do scientists take to freshen their breath? Experiments. I'm Isabel, and by the way, we're all identical triplets, as you can clearly tell. Our project is H2O 2.0, and we are the world's first water filter utilizing a common ingredient that has been overlooked for centuries as a means of cleaning impure water: rice. Our water filter works to filter contaminants, separate debris, and to neutralize or kill harmful bacteria.
For background purposes, our project was inspired by a group member witnessing a woman in poverty collect her daily water from a pond containing debris and animal feces. We realized that there is no economical product for those in need of a water filtering solution and set out to create one.
H2O 2.0 was born because of a need. In today's world, we are constantly developing scientific and technological solutions that could have only been dreamed of a decade ago. However, water is one of our most basic necessities, and we are yet to provide hundreds of millions of people with the solution they need. With H2O, a day's worth of water can be filtered in just minutes. Many people travel over 6 miles a day to get clean, fresh water, so this is a life-changing solution for them. H2O is designed to take a global issue and to solve it using basic materials found in a majority of homes worldwide.
Many people truly do not understand just how prominent this issue is. Worldwide, 780 million people do not have access to clean water on a daily basis. A common misconception is that all people in developed countries, such as the United States, have access to clean water. However, 63 million of those people are in the United States or U.S. territories.
The existing water filter solutions are not practical for the people who need it most. Store-bought water filters can cost around $200 to $2,000, a steep investment for those in poverty and with poor financial situations. Okay, this is our water filter. It doesn't look like much, but it's huge. It was built inside a plastic water bottle, but can be built inside essentially any durable container that can be punctured. First, we cut off the top of the bottle, as you can see, and then cut small holes into the bottom of the bottle to create a sieve-like effect. Then we pushed a small cloth to the bottom of the bottle to ensure only water got through. Then we poured long-grain white rice into the bottle to filter the water. Then we added small amounts of vinegar and lime juice to the water to balance the alkalinity and pH levels.
Once the water is put through this filter 5 times, taking about 10 minutes total, we tested the water using an EPA-approved kit. We tested the water to do more research on what bacteria had been neutralized, as well as the decrease in dangerous substances after filtering. It also helped to show that our water was significantly cleaner after putting it through a filter.
This success was only achieved after a total of 7 trials. Some worked more slow or allowed in bacteria. We decided to use the rice after learning of its absorbent properties during our 4th trial. This project has evolved from the first version, which included the unnecessary steps of boiling the water and running it through pebbles and grass. Our data supports our design statement because it proves that it is possible to build a safe, inexpensive, effective, durable, and safe water filter. From our various tests, you will see that our water filter is safe for users around the world.
Our water filter incorporated over 18 hours of research for maximum efficiency and appeal. After compiling a list of a dozen possible ingredients found in some of the world's poorest countries, we narrowed down our list to the 5 final ingredients, which you see in our filter today.
H2O uses a series of chemical reactions to balance out and neutralize various possible contaminants. The rice in the filter has the capability to absorb lead and iron in the dirty water because the magnetic properties of the iron and the lead are attracted to the rice. We then added small amounts of lime juice to the water because the rice tends to increase the pH level. We added vinegar to the water in order to help the alkalinity stay at a normal level, which it tended to decrease due to the addition of lemon juice. Overall, these 3 main ingredients work together to create a feasible solution to a crisis that is long overdue. Our filter box currently costs $2.18.
Our water filter is also presented to you in the entrepreneur idea of a water filter box or kit for the convenience of users. Our kit is small enough to fit inside a backpack or the trunk of a car or can easily be distributed. It prevents users from ever being in a situation where their only water is bacteria-ridden and dangerous.
H2O 2.0 is an effective and reliable water filtering kit that is global friendly and accessible to anyone in third world countries and in our community. Thank you for your time.
Thank you. Great job. Great job, absolute zero. And let's have a hand for all of our eCYBER mission finalists and all of our STEM in Action students. Great job overall. So, do we have questions for our final groups of students that just went on? Who's got questions? Colleen, are there? Oh, Colleen's got questions. What are the questions?
I got one. Okay, for ecstatics, where are you guys? Over there.
Ecstatic.
How much would a person need to walk to generate enough power to recharge your iPhone?
If you walk 1 mile, which is approximately 15 minutes, you can be on your iPhone for 24 minutes.
Wow. I don't know, that might end up being a better motivator than a Fitbit. If I know that I have to walk to charge my phone, I'd be pacing around my entire house all day just so I can make calls. We have a question right here. Oh, you need a microphone.
I have a question for Team Absolute Zero. So, like you guys said that like water filtration systems right now cost like a lot of money, but like I've heard of one like that you just like it's like a straw that you put into the water and it costs like $25. So like, what do you say to that?
So our response to that question is our water filter is $2.12, and the water filters we're talking about are permanent solutions. Some of the filters like those don't always work, and the other thing is they can't handle heavily contaminated water that has high amounts of debris because it's simply going to clog the straw.
Also, how much did you say this jug cost? Way more than ours. Ours is $2.18. So if you want a cheaper solution, we've got it for you. Just go to our website.
Well answered. So with that, how many votes did we end up with so far?
Last time I checked, we were over 5,600 votes, and you still have a few hours to get votes in, so till 8 p.m. tonight.
Yeah, 5,600 votes. So just a reminder, we've got 2 ways to vote until 8 p.m. tonight Eastern. Number 1, if you're currently on the Ustream site, right under your viewing box, there's a little button. It says Vote for People's Choice. You click there, you vote. Your other option, and you can do this from a smartphone, an iPod, you probably have to walk a mile in order to get a few minutes to do it. But you can go right to the eCYBER mission homepage, and you've got the link right there in order to vote for your people's choice. And again, that is 8 p.m. tonight Eastern Standard Time. So this has been a week, huh? And it's not over yet. The biggest part to come tomorrow. But I want to take a minute and ask all of our eCYBER missions to join me in once again thanking all of our SME mentors and our NCOs who have been with us this week. There you go. You guys, do you guys think you can make Sergeant Sanders proud and give her one really good hooah for the end? All right. And There's one other group of people we have to thank. We have to thank them for their kindness, their generosity. We have to thank them because without them, you would not be here literally because none of you are old enough to drive. The parents and guardians, where are they? Give them a big round of applause for this. So this was all an incredible week, right? Who wants to know who won? Well, you'll find out tomorrow. If you're here with us on site, you'll come to the awards banquet tomorrow. If you are out there on Ustream tomorrow, you will once again visit the eCyber Mission homepage where you will see a link that you can click to be able to watch our awards ceremony, root your favorite teams on, and of course, see who won People's Choice Award because you all did what? You voted. So, for all of you out there, you think you can do this, eCyber Mission, you have what it takes to accept the challenge. Do it. Don't wait. This is a great program. It's a great week. Great kids waiting for you. Take a minute right now. Check out eCYBER18.com to find out how you can get involved. There are other programs for older kids, programs all over this country. Take a minute, visit www.USAEOP, that is the Army Educational Outreach Program. You can find about great programs all over this country to engage in STEM. Help us create the innovation this country needs moving into our future. Meet some amazing kids, amazing people, and have an amazing time. So, one more time, let's hear it for our eCyber Mission National finalists in STEM in Action. All right, so that brings us to the end of our national showcase. Thank you so much for joining us this afternoon. Have a great rest of your week.
All right, everybody, thank you so much for being here for the national showcase. Students, stay